As data analysts, we usually focus on developing efficient, reliable, sustainable, and reusable models. To achieve these objectives, when designing data analysis solutions, we need to identify the target audience and consult potential stakeholders in order to understand the purpose for the model, its intended life, and any specific requirements around design, data layouts, functionality, and visualizations. We can then leverage our knowledge of Excel to evaluate various options that will help deliver on these desired objectives. For more complex solutions, we will also need to complement our Excel skills with certain design standards, practices, and considerations in context of the following activities: sourcing data from external systems, setting up reference data including lookup tables, input variables, and assumptions, using simple, transparent, and auditable structures to process and prepare data for analysis, and finally, presenting the desired insights and analytics within an easily consumable form. During Lesson 2, we learned how to get data from external source systems and transform it before importing to Excel. The course material from here on will cover the remaining activities around managing reference data, processing and preparing data for analysis, and presenting data insights and analytics. During this lesson, we will discuss the importance of consistency across Excel models and several ways to implement such consistency. We will review some considerations for writing formulas within complex models, discuss the importance of data integrity and some ways to implement it within our models. We will then create a reusable data quality dashboard using Excel charts, visuals, conditional formatting, and some other Excel capabilities. And then finally, we will design, implement, and populate a budget and forecast model with the concepts and skills we have learned thus far. So let's begin. When implementing complex Excel models that may need to be revised periodically, it is extremely important that we design our solutions for the desired long-term sustainability. Without a well-thought-out design, the final product might suffer on efficiency, reliability, sustainability, or worse, delivering on the key objectives. In such context, a combination of the following standards, practices, and considerations may be desirable: a consistent structure for our models, which may include standard worksheets, optimal data structures, and appropriate intermediary steps to simplify complex calculations. Use of naming conventions for worksheets, names, tables, and other data structures. Style definitions and consistent number formats for similar cells. Custom templates for cells containing specific data types that can be used as a model index, or the individual cells from such templates can be copied onto other cells within the model for consistency purposes. And finally, color schemes may be used with styles, templates, and data objects like Excel tables and dynamic arrays to distinguish between source, reference, and process data. Please note, you may want to consider other standards and practices depending upon your experience, client requirements, and emphasis on reusability. However, for the purposes of this fundamentals course, we will limit our scope to the topics listed here. With that, let's review these items in further detail. Excel functions and formulas are at the core of data processing within Excel. However, quite often Excel users will jump to writing formulas without understanding the overall structure and objective of the final deliverable. This is not recommended for complex models that need to be maintained over the long term. Since there are often multiple ways of implementing our requirements within Excel, it is important that before we begin writing formulas for our models, we spend some time to familiarize ourselves with the inputs for our solutions, including reference data, assumptions, input variables, and source data profiles, and the desired output formats, including visuals, layouts, and structures. Understanding the provided inputs and our desired outputs helps us to determine the intermediary steps and the appropriate data structures we should be using to simplify our model design and to introduce transparency within the necessary data transformations. We can then determine how our formulas will be copied, moved, or filled within our model. This allows us to write formulas with an appropriate mix of cell reference types in order to minimize the number of unique formulas we must write and to allow for more efficient, sustainable, and reusable formulas. When implementing complex calculations, it is best to break down the problem into smaller components. While this may require us to introduce multiple steps, potentially across multiple worksheets, before getting to the desired results, it will ensure that our authored models are easy to develop, understand, and maintain over the long term. In some cases, we may need to use intermediary data preparation worksheets to perform detailed calculations before summarizing the results onto a report or summary page. This will also allow for more transparent data processing within our models. In general, we should avoid long and complex formulas and try to simplify them by exploring alternate functions, data structures, or approaches to solve the problem at hand. Keeping our formulas short and simple enhances their readability, development, and future troubleshooting activities. In the same context, it is also recommended to add some structure for our formula code. This will further improve readability and future support activities. Such structure may include a space after commas and opening brackets, before closing brackets, and around mathematical or logical operators like plus, minus, ampersand, equal, etc. We can also use new lines within formulas by using the Alt plus Enter key combination. Lines can typically be added within multi-parameter functions like if, after logical breaks within a long formula, and after specific parameters within a long function. For example, the multiple criteria range and criteria pairs for the SUMIFs function. Now let's look at some examples for how some structure within our formula code can help. For these examples, we'll use a couple of variables, a and b, as listed in the top left. For our first example, we have a simple formula in cell B10 which compares the value of these two variables to then output an appropriate result. As you can see, this formula looks like a long string of text right now. Now let's try to add some of the structure elements that we just discussed. So we'll add some spaces around the brackets and operators, after each parameter, and just before the final closing bracket. We will also add new lines after each parameter, and then press Enter to refresh the code layout. When we press F2, we can see that the formula now is much more readable than its previous version. We can clearly identify the individual arguments for the if function, including the expressions for the true and false values. Now let's try to implement this for some more complex formulas. Here, we'll use the same variables to look up the corresponding result values from the table above, and then sum those values to calculate the result. For the first formula, we will use matrix multiplication with the sum function. For this example, I've already added the spaces as we discussed previously. Now let's try to identify some logical breaks within this long formula and add new lines at those locations. Typically in these cases, we'd want to add a break just prior to an operator. So in this example, we'll add a couple of new lines just prior to the multiplication operator. As you can see, by just adding those two new lines, the formula is much more readable than before. We can now easily identify the 3 arrays that we're using for our product. Another variant of this formula can be written with the SUMIFs function. Similar to the previous example, we again have a long string of text for the formula code. However, we have multiple parameters here, which can be typically used for new line breaks. Now let's look at the syntax for this function. As you can see, we have an initial sum range, and then pairs of criteria ranges and the corresponding criteria. Thus, a logical spot for the new line breaks could be after the initial sum range, and then after each criteria range and criteria pair. Again, by just adding those 2 new line breaks, we can easily identify the field we're calculating the sum for and the 2 criterias being used to calculate that sum. In addition to the layout of our models and the structure within our formula code, the following tips may also be beneficial when authoring formulas in Excel. When simultaneously reviewing the formula code for multiple cells on a spreadsheet, we can use a single code prefix to disable formula evaluation and display the formula text in the same cell. We can also use the Ctrl plus grave accent key keyboard shortcut to toggle between formula code and their resulting values on the current sheet. The grave accent key is typically found under the escape key on our keyboards. To evaluate specific parts of a formula, we can use the Evaluate Formula option under the Formulas tab on the ribbon bar. In the resulting dialog box, we can individually evaluate different components of this formula and in some cases, we can even step in and look at the underlying references. We can then step out, look at our calculated values, and complete our evaluation. Once done, we can simply click on the Close button and exit the dialog box. Another way of evaluating specific parts of a formula is by simply selecting the part we want to evaluate and then press F9. To switch back to the formula text, we can use the Ctrl plus Z keyboard shortcut. This is the typical undo shortcut on our keyboards. Lastly, we should avoid using constants within our formulas and duplicating formula code across multiple cells. In both these cases, we should instead use the Define Names capability within Excel to either reference the constant from the input sheet we discussed previously, or the result of the formula either entered in a cell or within the expression of a defined name. So with that, we have now covered the topics related to authoring formulas for complex models. We will be using some of these concepts to develop a data analysis solution later in this course. Data integrity refers to the consistency, accuracy, and completeness of a dataset. It is a critical requirement for any data analysis solution where we need to generate reliable and actionable insights by processing raw data. Without this key aspect, the resulting insights could be incomplete or worse, misleading. In the context of this course, data completeness implies having access to all data required for our analysis. Accuracy refers to a key requirement for having correct and validated data, which may be entered manually, sourced from another system, or processed and reported from our solutions. And finally, the third attribute for data integrity requires that all data should be created, accessed, processed, and presented in a consistent manner. As data analysts, we can apply sound data integrity practices to uncover numerous benefits for our solutions. Such practices can help us to be more efficient as we build sustainable solutions that can consistently generate accurate results in a timely manner. Some benefits of implementing and maintaining data integrity within our solutions include
identifying and removing duplicate data, which allows us to maintain referential integrity within our datasets, consistent business rule and logic implementation, which results in reliable lookups and calculations within our solutions. And the primary benefits for end users include timely and accurate reporting. Modern database systems provide a variety of options for implementing and maintaining data integrity. Obviously, Excel is not meant to be a database and is thus lacking in such capabilities. It is thus imperative for us to implement and maintain a certain level of data integrity within our Excel-based solutions that either bring in data from other systems or use manually entered data within Excel. Let's first look at some challenges related to implementing and maintaining data integrity within Excel-based solutions. Later in this sublesson, we will discuss some options to get around these challenges. Now, for most data analysis solutions, we import data from other sources, typically databases, and then try to collectively process this external data in addition to any manually entered data we might have set up within Excel. As we do this, quite often we will need to relate some of these data sets for lookups, validation, appending, merging, and so on. Although more recent versions of Excel provide data modeling capabilities, which are outside the scope of this fundamentals course, it generally lacks basic features for relational data sets, like the ability for assigning primary and foreign keys, or other built-in capabilities for defining and maintaining relationships within our datasets. Moreover, the most common use for Excel is data entry or creation. As such, it comes pre-packaged with certain built-in features to facilitate such activities. One such feature is auto-formatting and conversion of data when importing or entering it into Excel, and in some cases, when working with data within Excel formulas. For example, default text format for dates within Excel is based on the Windows system settings. Since this can change from one machine to another, importing date data from CSV files may sometimes have undesirable results. In other cases, textual data without letters may be interpreted as numeric, which causes issues for fields like order numbers, where we might have some leading zeros. And since Excel stores dates as numbers, some numeric fields may be interpreted as dates within Excel. Finally, Boolean values or results within Excel formulas will be automatically converted to a 0 or a 1 when used with mathematical operators. Apart from the data import and processing related issues we just looked at, Excel also lacks comprehensive capabilities around access provisioning, data quality controls, audit trails, version control, and structured workflows, including approvals. Since we typically import data into Excel and then process it to generate the desired outputs, we also run the risk of misconfigured inputs and unintentional changes to formulas used for data processing. Additionally, unless we store our Excel files on platforms with built-in version control features like OneDrive or SharePoint, we also need to plan for the risk of a potential Excel file corruption. Now that we have reviewed some common challenges with data integrity within Excel, let's look at some ways to address some of these challenges. In such context, Excel provides several features and capabilities that can help us to implement certain data integrity controls for our solutions. To start with, there are a few categories for Excel functions that can assist with avoiding, identifying, and handling issues related to data integrity. These functions can be reviewed under the following categories within the Functions library on the Formulas tab of the ribbon bar: Logical, Lookup and Reference, and Information under the More Functions group. In addition to these functions, we can make use of the data validation and conditional formatting capabilities within Excel to further support data integrity related measures. Within Excel, data validation is used to restrict the type of data or the values that users can enter in a cell. One of the most common data validation uses is to create a drop-down list, also known as a data validation list. Conditional formatting, on the other hand, is used to selectively change the appearance of cells or ranges based on certain conditions that we provide. Now let's review an example that uses some of these capabilities. So for this example, we have a student list with their ID, first name, and last name in the student master table on the top left here. And then we have another student data table, which has other data for individual students. To ensure completeness, we would want to check if the IDs available within the student data table are also available within the student master table. We'll probably want to highlight the records that are not available in the master. And then we'll also pull in some data from the master table into the student data table to generate the full name for each student. In order to create the link between these two tables, we'll try to retrieve the index of each student record in the student data table from the student master table. To do that, we'll use the xmatch function, and the value we want to look up is the student ID for this row, and we want to look it up within the ID column of the student master table. Since we're looking for an exact match, we'll use 0 as the third argument, and then press enter. As you can see, for each row in the student data table, we have now pulled in the correct index from the student master table. In case one of the student IDs was not available within the master data table, so let's say ST06, the formula we just authored returns an error. Ideally, we should handle this error and return a friendly message. So in this case, we'll use the if_error function, and we'll check the value returned by the xmatch function. And if that is an error, let's say we'll just return the empty string. As you can see, the record that previously returned an error now displays an empty string. To take this a step further, we may want to highlight the cells that return an empty string for the match index. To do that, we can select the entire column and then choose one of the conditional formatting options under the Styles group of the Home tab on the ribbon bar. Here we have options to highlight cells based on their values or how their values compare to other values within a selected range. In our case, since we just want to compare the value to an empty string, we can look under the Highlight Cell Rules group and then look for the equal to option. Here we can provide the value we're comparing to, which is the empty string, and then select an appropriate format for the cells we want to highlight, and then press OK. As you can see now, the cell with the empty match index is highlighted with the format that we just provided. Next, we'll try to pull some data from the student master table into our student data table on the right. To do that, we'll use the index we just calculated so that we don't have to handle any error scenarios again. So we'll start the formula by checking for the index. And if it is empty, we just want to return an empty string for the full name as well. If it is not empty, however, we want to concat the first name of the student, which is the value within the first name column of the student master data at this index. And then we add a space between the first name and the last name, and then repeat the same formula for the last name. We'll then close the brackets and then press enter. As you can see, we've successfully pulled in the full name for each student, with the exception of the student that wasn't available in the student master. Now let's build on this example and look at another table, student grades. Here, we want to enter the grades for individual students for the different subjects they might have enrolled for. In order to ensure accuracy for the data entry, we would want to limit the IDs in this first column here to only the values available within the ID column of the student master table. Similarly, we want to limit the subject field to only the values available within the code column of the subject table to the left here. To enforce such constraints on data entry, we can use the data validation feature of Excel. This feature allows us to limit the content of a specific cell to either a list of values or to a specific format. To use this feature, we go under the Data tab of the ribbon bar and then click on the Data Validation button. We'll start with the Settings tab here and look at the options available for the Allow setting. Here we can select the data validation type that we want to enforce for this cell. The different options are a whole number, a decimal, a list of values, which is what we're going to use for this example, dates and times, text with a specific length, or any other custom formula that results in a Boolean true or false value. Now, since we want to provide a list of values for this cell, we'll use the list option from this dropdown. For the source setting, we can simply click on the entry box here and then select the values that we want to include in the list. Next, we'll press OK and then validate if we get the list of values in a dropdown. Now, before we implement a similar dropdown for the subject column, we will copy the standard format that we have implemented for dropdowns in this model. As we discussed earlier in this lesson, such formats would include the cell formatting options and the standard input and output messages for our dropdowns in this model. These formats would typically be stored on the Formats sheet within the same model. Now let's select the drop-down template here, copy, go back to our data integrity sheet, and then paste it in the subject column. Now, while selecting the same cell, if we click on our data validation button, we can see that it has the standard input and error messaging already included. Going back to the Settings tab, we notice that we should probably change our source for this data validation to something more relevant for this cell, which in our case is the subject codes. And then we click OK again, and notice that Excel is complaining about the value in this cell. If we open the list, we'll see that the values expected in this cell are now the subject codes. However, we still have the original value of 1 entered in the cell. As we clear this out, it will also remove the warning message from Excel. Now, if required, we can implement another data validation for the grade column in this table to ensure that only decimal values are allowed. However, we'll skip that for this example. Please note that the source reference for our drop-down lists can also accept a formula that returns a list of values. For example, we can use the indirect function with a structured reference for an Excel table, or we can use a define name that uses the same structured reference, or maybe a dynamic array formula to return the list of values. Using such options, we can reference a dynamic list of values that can change without impacting the drop-down list. We will review some examples of such approach later in this lesson. In addition to the use of Excel capabilities we just discussed, there are other measures that can be implemented to improve data integrity within our models. For example, we can list some input data and other critical processed information on the same worksheet as the generated outputs from our model. This allows the end users to review such inputs in context of the processed results and potentially identify any discrepancies. We can also implement worksheet and workbook protection to prevent unintentional edits to formulas and formatting. We will be reviewing this topic in further detail later in the course. And finally, if we're working outside of solutions that include version control capabilities like OneDrive and SharePoint, then we should be making periodic backups of our Excel files to support potential data recovery activities. So with that, we have now covered the critical concept of data integrity in context of Excel-based data analysis solutions. Over the remainder of this lesson, we will now design and implement a couple of examples to demonstrate the skills we have learned thus far. During this sublesson, we will create a data quality dashboard that can be used to review the data within any column of a table within our model. Once completed, this dashboard can be used to evaluate the data quality and profile for the specified column, and to identify values within the column that do not match an expected format. The data available for this demo includes an employee data table with their name, date of birth, age, phone number, and state. For a successful implementation, it is required that the user be able to enter a table name and then select a column for that table to analyze using the calculations and visuals on the dashboard. Furthermore, the design for our dashboard should allow it to be copied across multiple models for consistency and reusability. The ability to standardize such capability within our models will provide us with quick insight into our source data, which can help avoid some data integrity related issues we discussed earlier in this lesson. Throughout this demo, we will use the concepts and functions listed on this slide to generate the following information for our dashboard: total number of values in the selected column, top 10 distinct or duplicate values, values that do not match a given format, count of empty cells or cells with errors, total number of distinct, unique, and duplicate values, count of values within the selected column that are not a number or maybe are 0, invalid dates or dates that are in the future, and finally, the min, max, and averages for the values in the selected column. So with that, let's begin. So as you can see, I've already got a layout for our dashboard with a couple of data entry fields in the top left, which is for the table that we're going to analyze and the column within that table that we're going to look at. The couple of fields below that are some calculated properties for the selected column. To the right of this, we've got a couple of sections for the column quality and profile. And then below that, we've got another section for the data profile for the values within the column. To the right of that, we've got some empty space where we're going to place a couple of visuals for the top 10 distinct values and the top 10 duplicate values within the column. And below that, we've got a couple of boxes where we'll place the spill ranges that become the source for these two visuals. And we can also use these to validate the data within the visuals. Then to the extreme right, we've got the format check section, where we can evaluate the values within the column for a specific format, and then display some corresponding results in this section here. Off our screen to the right of the dashboard, we've got the tabular data that we're going to reference. So here we've got the name, date of birth, age, phone number, and state for the employees. We've named this table DQD_TBL emp data, So this follows our standard naming convention where we've got the sheet acronym to start with an underscore following that, then the TBL prefix because we're referencing tabular data, and then an appropriate name for the dataset. Coming back to our dashboard, we've also got some defined names that I've set up in advance just to save ourselves a little bit of time. Some of these defined names are listed right next to the fields or cells that they reference. And then there's some others at the bottom that we're going to review as our demo progresses. You can see that all our defined names also follow a consistent naming convention. So we've got the ARR prefix for the arrays. We've got an FC underscore for the format check section on the right. And then all of them in general have the DQD underscore prefix added for the sheet that they're on. So with that, let's begin our demo and start building our dashboard. To start with, we'll specify the name of the table that we want to analyze, which is DQD underscore TBL emp data. This is the table we just looked at. Now, if we click on the column to analyze cell and look at the drop down in this cell, we'll see that it's already populated with the column names for the table that we just referenced. Now, this is because I've already set up a data validation for this cell, but let's have a look at the formula we use for that data validation. So we'll go to data and then click on data validation. So here we've used the list option under allow. And for the source, we've used the indirect function with a textual reference to the headers of the table. For that, we use the define name for the table to analyze, which is referring to cell B4 here. And then we've concatenated the pound headers suffix for the structured reference to the headers of that table. So using this formula, we're able to display the column names in the drop down for this cell. So let's select one of the column names. And then let's generate the structured reference for this column under column reference text. For this, we'll use the concat function. We'll start with the table name and then open the square brackets. And then we want to reference the column name and then close the square brackets and then press enter. We can now use this structured reference for the selected column for other formulas within this dashboard. The first formula we'll use this for is to determine the data type of the first value within this column using the type function within Excel. We'll also use the DQD underscore column ref define name, which uses the column reference text that we determined up above and supplies that as an argument for the indirect function to then reference the actual values within the selected column. And finally, we'll use the Excel data types lookup table that we've created on the ref sheet, which maps the data type names to the numeric value returned by the type function. Now let's start entering our formula. We'll start by retrieving the first value in this column using the index function. We'll use the DQD underscore column ref define name and then supply the row number argument as 1 because we want to get the first value. And let's press enter. We will now use the type function to retrieve the data type for this value. And we can select the entire expression and use F9 to look at the calculated value. Using Ctrl-Z, we can get back to the formula. Then we'll use the X lookup function to look up this numeric type value in the type column of our Excel data types table. We can reference that using the acronym for the sheet. It is tabular data. And then now we can get to the Excel data types reference and then supply the type column name. The value we want to return is within the name column of the same table. And let's also provide the if not found argument. And we just want to return unknown if nothing's found. And then the search mode is 0 for exact match. And then we press enter. As you can see, we get the text data type for the name column. Now let's try for the age column. And we get number. So our formula seems to be working. Now let's generate some stats for this column. We'll start with a count of all blank and non-blank values within this column. So we'll use the count blank function and the count a function for all non-blank values. As we press enter, we can confirm that we've got the right result, which is a total of 25 rows within our table. For the next stat, we only need a count of the blank values. So we'll use the count blank function. And then we'll get a count for the number of errors in this column. I know I've got one error in this column, so let's see if we can get that result. For this formula, we first want to check if the value is an error. So we'll use the isError function. And if the value is an error, we want to increase the count by 1, or else leave the count as is. We want to then sum all the counts to get the total number of errors in this column. As we press enter, we can confirm that we have the expected result. Now let's move on to the column profile section and look at the formula for the distinct count. Here, we'll start with the countIf function and provide the column reference for both arguments, and then close the brackets. Using an array as the criteria argument for this function tells Excel to loop through the range for each value in the criteria array and calculate the corresponding count. Using F9 on this expression, we can see that the count for each value in the column has been returned in an array. From here, if we divide 1 by each of these values and sum all the results, we'll get the total distinct values in this column. However, please note that we have some zeros in this array as well, which will probably result in a divide by 0 error once we enter the formula. We should thus handle such error before summing the results. Using Ctrl-Z to get back to the expression, we can continue with the formula. We'll first divide 1 by this array result, and then check for the error. And in case we have an error, we want the value 0. And finally, we want to sum up all the results. Pressing enter, we can see that there's 15 distinct values in this column. Using a similar approach, we can calculate the number of unique values in this column. Here, we'll use the same COUNTIF expression and then check for the value to be 1. If it is 1, we want to increase the count by 1, and if not, then we just want to add another 0. Finally, we want to just sum up all the results. For duplicate value count, we can subtract the number of unique values from the number of distinct values in this column. Next, for the not a number count, we can first determine a count for the numbers in this column, and then simply subtract that from the total count for this column. Here, we'll use the isNumber function to check individual values in this column, which returns an array with Boolean values, which we can then use with the mathematical operator to convert to numeric values. We will then sum these results and subtract from the total count. For the zero value count, we can simply use the COUNTIFs function and check for zeros. Moving on to the data profile section, we can use the standard Excel functions for min, max, and average to get the corresponding values for this column. However, we probably want to include some code to handle the error values within the column. For that, we'll start typing our standard function and then use the ifError function within it. With this, we're telling Excel to replace any error values within this column with the blank value. We can use similar functions for the max value and the average value. Now, before we author the formula for invalid dates, it is important to note that date and time values in Excel are stored as numbers, and our formulas will leverage this property. So for invalid dates, we're going to count the number of values in this column that are either not a number or that are a number less than 0. To do this, we'll first use the filter function for the values in this column that are not a number or that are less than 0. It is important to note that we've used a plus sign for the OR operator in this expression. This is because we're dealing with array results in this expression. And for arrays, the plus sign acts as an OR operator, and the multiplication sign, or star, acts as the AND operator. Now let's press enter on this expression. As you can see, we've got a divide by 0 error here. That's because our age column does not have any dates within it. Thus, there's 0 rows for the filter. To handle this better, we will use the ifError function around the filter function. And if there is an error, we want to return 0. Now we've got one more thing left. That is to count the number of rows returned by the filter function. We'll use the rows function for that purpose. If we now select the date of birth column for our analysis, we'll see that our formula returns a single invalid date, and that matches our expected result. Continuing with the other date-related profile, we'll check for the number of dates that are in the future. To do this, we'll use the COUNTIFs function for the values in our formula and check for values where they're greater than today. For the criteria argument of this expression, we're concatenating a string with the greater than sign, and then today's date. Excel uses this expression to qualify each value in our column to then return the final count that matches our criteria. Now, before we look into the visuals for the top 10 distinct values and the top 10 duplicate values, let's change the column to Analyze to our name column, and then look at a couple of defined names that we'll be using for this exercise. The first one we'll be looking at is dqd_array value counts. Here, we'll generate a two-dimensional array with the distinct values in the first column, and then the counts for those values in the second column of the two-dimensional array. To start with, we'll use the countifs function to get a list of counts for the values in this column. Next, we'll add the distinct values as a column to this array. For this, we'll use the choose function, where we'll provide an array argument for the index num argument, and then the column reference itself for the value1 argument, and then leave the countif function as the value2 argument. Here, we're telling Excel to choose the first and second value from the list of values that follow the first argument. If you remember, commas within array constants are used to separate individual fields within the same row. Thus, with this array constant as the first argument, the return dataset will have the value and its count in the same row of the two-dimensional array. As you can see, we have some duplicate values in our dataset. To remove those, we'll use the unique function and provide our array formula as an argument. We're then able to copy this formula and provide it as the reference within our dqd arr value counts defined name. The other defined name we want to look at was the dqd_array duplicate values. Here, we want to return a two-dimensional array with the values that occur 2 or more times in the selected column and the count for those values. For this, we can just filter our value counts array that we just defined, where the count, which is the second column in the same two-dimensional array, is greater than 1. Now let's use these defined names to generate the data for our visuals. To start with, we'll sort the value counts array based on the count column, which is the second index, and in descending order. Next, we want to get the top 10 values from this list, so we'll use the index function. And for the row number argument, we'll provide the first 10 indices. For the column argument, we need the first column, which is the value column, and the second column, which is the count column. Similarly, we'll enter the formula for the duplicate values data set by replacing the array reference to the duplicate values array. As we press enter, we'll notice that some of the cells here return an error. That's because we don't have enough values to provide the top 10 from this array. To handle this error, we'll again use the ifError function. And in case of an error, we just want it to return a blank value. Now that we have our data sets ready, let's work on the charts above. We'll start with the distinct values chart and click on the leftmost header cell for our data set. With this cell selected, we'll go under the Insert tab on the ribbon bar and then select the chart type we want to use. Because we have text values for our category axis, typically a bar chart is suitable for such cases. We can now drag the chart to align it with the header above and press the Alt key while we're doing this to snap it to the cell edges. We'll then drag the bottom right edge of this chart to resize it to our desired space. We'll again press the Alt key to snap it to the cell edges. With our chart resized, let's work on some of the formatting options. To start with, we'll select the value axis below and click on the plus sign in the top right of the chart. Here, we'll uncheck the chart title and the grid line options. We'll also go under the Axis submenu by clicking on the black arrow and uncheck the primary horizontal axis. We can click on the plus sign again to hide the options menu. Next, we'll right-click on one of the bars in our series and select the Format Data Series option. We will then go to the Fill and Line tab and select Solid Fill to get the orange shade. Next, we'll go to the Chart Elements drop-down at the top and select the Vertical Category Axis option. Here, we'll go to the Axis Options tab and then select the Categories in Reverse Order checkbox. This will sort our chart data in the same order as the spilled range below. Now let's try to replicate the same process with the duplicate value. With the leftmost header cell selected again, we'll go under the Insert tab on the ribbon bar, and then this time we'll select the clustered column chart. As you can see, Excel failed to pick up the right chart data this time. This is due to the empty cells within our data set. Now let's try to fix it. So we'll click on the chart, go under Chart Design, and then click on Select Data. Here we'll notice that the chart data range shows the correct range selected for our data set. However, the series and category axis labels aren't configured correctly. Let's work on the series first. This is where our count data should show up. So the series name should be count, and the series values should be all numbers within this column. Moving on to the category axis labels, this should have all the values within the value column of our data set. Accepting the selections, and then finally clicking OK on the Select Data Source dialog box. We can see a more decent chart now. However, I think we can do better. However, before we proceed with the formatting, let's resize this chart and put it in the allotted space. We'll use the Alt button again to snap the edges of the chart with the edges of the cells and work to get it in the same size as the distinct values chart to the left of this. Now let's carry on with the formatting options. Again, we'll click on the category axis and then the plus sign. We'll uncheck the chart title and the grid lines. And then under the axis submenu, we'll also disable the vertical axis. We'll click on the plus sign again to hide the context menu, and then right-click on any bar in the series. Select Format Data Series, go under Fill and Line tab, and then select Solid Fill option. From the colors, we'll select the orange color again, and then move on to the category axis from the Chart Elements dropdown. Here, we want to have the individual category labels more readable. So we'll go under the Text options, and then the Text Box tab, and then we'll add a custom angle of -60 degrees. Next, let's fix some of the issues with the data and column profile cells. As you can see, our average value currently shows a divided by 0 error. This is because for the name column, it cannot find values to calculate an average for. We'll fix that again using the if_error function. And if there is an error for this formula, we need the value to be returned as 0. We'll also set center alignment for the column quality cells from the Home tab. In addition to that, we should probably highlight some of these values in case they're greater than 0. We'll do that for the empty and error counts, for the duplicates, not a number, and then invalid dates and dates in future. With the cell selected, we'll go under the Home tab on the ribbon bar, expand the conditional formatting options, and then the highlight cell rules, and then select the greater than option. Here, we want to show a red formatting in case the value is greater than 0. As you can see, the selected cells with values greater than 0 are now highlighted. Now to wrap up this demo, let's get to the Format Check section to the right. In this section, we'll use Excel wildcards to compare the values in our selected column to an expected format and list some of the corresponding results below that. As you can see on the screen right now, Excel allows a couple of wildcard options: a question mark to look for a single character, and an asterisk to look for a number of characters. Both these wildcard characters can be prefixed with the tilde symbol to search for the character itself. Now before we author any formulas for this section, I'll change the name of our selected column to phone, and then review the format we expect for the values within this column. You'll also notice in the top left that I've already defined a name for the cell containing this format. Now for the first formula in this section, we need to calculate the total number of values in this column. You'll probably remember that we've already calculated this value. So here we can just reference the previous cell, press F4 to change this to an absolute reference, and then press Enter. For the next formula, we'll use the COUNTIFs function to search the selected column for the expected format that we've listed above. Please note that we've used the COUNTIFs function because it inherently handles the wildcard searches. Now for the last part of this demo, we've got a spill range here that displays the first 5 values from our selected column that do not match the expected format. In addition to that, in the first column, it displays the row number in an original data set for this specific value. As you can see, I've already authored a formula for this spill range. We'll try to replicate this formula in the cell below. To start with, we want to generate a two-dimensional array with the first column being the row number for each value in our selected column, and the second column being the value itself. To do this, we'll use the choose function and a similar approach that we used previously on this dashboard. For the second argument of the choose function, we'll use the sequence function to provide us an incremental row number for each value that we pick up from the third argument. Here, we'll provide the sequence function with an argument for the total number of rows in our selected column. And now for the third argument, we'll provide the column reference itself. Next, we want to filter this array for the values that do not match our expected format. So we'll use the filter function. And for the include argument, we'll use a combination of the isIter and the search functions. The search function also handles wildcards and returns an error if the search text is not found. So we'll provide the expected format as the find text argument, and then we'll provide our column reference for the within text argument, and then we'll provide the start number to be 1. To finish the filter function, we'll provide the if empty argument to be none found. As you can see, the formula now provides the values that do not match the expected format and the corresponding row numbers for these values. However, we want to limit this array of values to a total of 5 rows. So we'll use an approach similar to what we did for the duplicate values dataset. And we'll use the ifIter to handle the errors where the total number of rows returned is less than the maximum rows we expect. And then use the index function for the current array formula. For the row numbers, we'll use a sequence with a 5 argument because we need a total of 5 rows. And then for the column argument, we'll use 1, 2 to get the row number and the value columns. We'll complete the index function, and then in the next line, we'll provide a blank value for the ifIter argument. As you can see from the blue border now, our spill range includes 5 rows. Okay, so with that, we have now completed our demo for the data quality dashboard. We hope you enjoyed it and that you'll be able to leverage these skills within your next Excel model. For the remainder of this lesson, we will use a story-based learning approach in order to design, develop, populate, and use a budget and forecast model. At a high level, we will go over the following activities during these lessons. Review the scenario and define a problem statement. Identify stakeholders and gather requirements. Design a layout for our solution in order to deliver on the requirements. And then based on the layout, we will identify appropriate data structures to be used, and we will determine how our formulas may be copied, moved, or filled within our model, so we can include appropriate cell reference types. Finally, we will populate data within our model and generate some insights and analytics. During this sublesson, we'll be focusing on these highlighted activities. The remaining activities will be discussed sequentially in the following sublessons. So with that, let's begin. For this scenario, you're an experienced data analyst who has been recently engaged by an executive you have worked with in the past. Emily is the new CFO for a well-known bike manufacturer. She has spent a couple of months in the new role and has identified a few process improvements she would like to implement. One of the first opportunities she wants to tackle is improvements related to the budget and forecasting process. Talking to her direct reports, she has come to know that a significant amount of effort is spent by one of her teams to provide weekly reports for other business units. One of the most common requests is for the revised sales and operating expense data. Managers within the business units use this data to forecast their revenues and operating expenses for the year and to create and maintain their budgets for the next year. Providing an efficient, reliable, and sustainable solution for this repetitive request can free up considerable time for Emily's team. She also wants to consolidate the budget and forecasting process within her team for consistency and enhanced reliability. Since Emily has worked with you in the past, she is confident that a relatively simple Excel-based solution can help to deliver the desired benefits. About a week ago, she had asked you to discuss this further with the stakeholders and prepare a relevant proposal. Now let's review some of the findings. Talking to Emily, you have identified the need for an efficient, reliable, and sustainable solution that includes the following: a categorical summary for the revenues and expenses for the current and 2 prior years, a consistent forecast for the current year's net profit, a flexible template to generate budgets for the next year by combining a variance input with historical data for each category, and finally, some visual aids to summarize the results and highlight some predefined data insights. For this opportunity, you engaged a few stakeholders over the last week, including Emily, the CFO herself, an accounting manager who is responsible for recording sales and chart of accounts, 2 accounting technicians who generate the weekly reports, representatives from the business units who consume the reports generated by the technicians and also provide budget input for Emily's team, and then a couple of teams within IT to discuss database access and security approvals. Based on your discussions with these stakeholders, you were able to document the following requirements for your solution: import sales, expense, and budget data from the corporate data warehouse, prepare an income statement template with the revenue categories and totals at the top, followed by operating expenses and then the net profit at the bottom. Next, forecast the net profit for the current year by prorating year-to-date actuals beyond the analysis date. This date should be set up as a manual input for the model and will also be used to limit the sales and expense data imported from the data warehouse. For budget generation, each category of revenues and expenses should have the flexibility to include a percentage or dollar amount variance with one of the following base values: average of actuals for last 2 years, actuals from last year only, original budget for the current year, or the forecast generated for the current year. Finally, the model should provide visual aids to highlight by category the variance between current year's budget and forecast, and the current year's budget and next year's calculated budget. Other visuals requested by the stakeholders include a categorical breakdown for the current year actuals for revenues and expenses, a comparison between budget and forecast for the current year by category, a similar comparison for the actuals from last year and the forecast for the current year, and finally, a graphic comparing budgets for the previous, current, and next year. So equipped with this summary of her findings, let's begin by designing the sheet layouts within our model. These layouts are rough drafts for how our content will be structured on the worksheets within our model. They are a critical design component when developing complex Excel solutions, as a well-designed layout will be useful both for the data analyst and the end users. While such layouts enhance productivity for the analyst, they also allow the end user of the data package to follow a clearly articulated story by presenting the data sources, transformations, and insights in an easily consumable form. So with that, let's begin. So here I've already created the worksheets that we'll be using for this model. In addition to the standard worksheets that we discussed earlier in this lesson, like info, ref, and input, I've also created some model-specific worksheets for the source data, for preparing data for analysis, and finally, report pages to summarize our results and other data insights. For this scenario, we will assume that we've already used the get and transform capabilities discussed during lesson 2 to import our source data into the Excel tables created on the sheets with the SRC prefix. However, I would like to highlight some calculated columns that we have added for these tables to optimize our data processing activities. For our budget, sales, and OPEX tables, we have calculated the year corresponding to the date column for each data set. For our sales data, we had to include an additional step to calculate the order date formatted column. This column was required since the date format in our source data used a /, while our system settings included an hyphen for such format. Due to this mismatch, Excel was not able to recognize the values in these columns as dates. So in this case, we split the source date string into the year, month, and day components, and then supplied them to the date function for generating the corresponding date value. With the data import completed, we plan to combine our source data with the other inputs we have set up on the input sheet to prepare our data for analysis on the prep budget sheet, and then finally summarize the results onto the RPT budget sheet. For our current exercise, we'll review key elements of our prep sheet design and then discuss a proposed layout for our report worksheet. First, for our prep sheet, let's go over some design-related requirements that we identified from our stakeholders. One of the primary requests was to lay out our revenues, expenses, and net profit data similar to an income statement. As you can see, we have replicated the desired structure with this layout. Our revenues are listed first, then operating expenses, and then net profit at the bottom. We have also included the totals row for our revenues and operating expenses. Now this requirement alone determines the vertical layout for our prep sheet. For the horizontal data flow, we should probably consider which data points are now required for each of the categories listed on the left. Reviewing our requirements again, we can identify the actuals for the current year and the 2 prior years, budget for the current year and the previous year, a forecast generated for the current year, which can be aggregated to get us the net profit forecast requested by the stakeholders. Next, for each category on the left, the users also wanted to have an option to specify a percentage or dollar amount variation for a predefined base value. For this requirement, we will have a drop-down selection for the users to select a base metric, which we can then use to retrieve the corresponding base value. For example, average of actuals for the last 2 years, the current year budget, and so on. The users can then enter their variations for this base value in column M or N. We can then use the selected base metric and the entered variations to calculate our budget for the next year. We can also use conditional formatting to highlight the variations between the current year budget in column G and forecast in column I, and between current year budget in column G and next year's calculated budget in column P. In addition to satisfying our user requirements, we will display some additional information related to our input data so the users have it accessible with the output generated on this page. As discussed earlier in this lesson, such practices can help to identify any input data issues that may lead to misleading results. The specific information we list here is the analysis date, current year, and budget year in the top left, and the numeric year values within the header of each column that references previous years, the current year, or the budget year. We have also used some cell styles and color schemes within this layout. For example, all field titles in the top left use the cell style SCL-field title 01. The level 1 column headers use the cell style SCL-H1, and the level 2 headers use the style SCL-H2. Additionally, the manual entry fields use the cell style SCL-input, while the drop-down fields use one of the templates from the format sheet and are highlighted in light red. Next, we have added some notes to annotate the functionality of some fields. For example, the forecast column header includes a note for the proration approach for this calculated field, and the $change column header includes a note that specifies that this field overrides the %change field. As discussed earlier, these notes will be easily accessible for the end users and will thus introduce transparency for our data transformations. And finally, we have used the built-in outline feature to group similar data for budgets, forecast, and budget variances. Later on, we will apply similar outlines for the revenue and operating expense categories on the left. Now moving on to the design for our report page, we have a total of 8 visuals that are required for the requested data insights. The 8 visuals can be broken down into 4 pairs, with one each for revenue and operating expense categories. For the most part, we would want to keep the pairs together, preferably in a similar layout as our source or prep data. In this case, that would mean that we should have our operating expense data below our revenue data. At the same time, we need our visuals to be legible and avoid using a white format for our page to prevent any printing issues for this report. To get around these constraints, we lay 3 pairs of visuals side by side, and then for symmetry, we split the remaining 2 visuals across the width of the other pairs. Since this is a budget and forecast model, we would want to maintain the focus on budget values, and as such, we display the corresponding visuals at the top of the page. For each visual on this layout, we have also evaluated the type of data being summarized and the allotted size for the specific visual to then determine the type of Excel chart we can use. Please note that although we may change this report layout or the identified charts later on, this template is extremely useful to propose a design for our stakeholders and gather appropriate feedback. So now that we have discussed the general design for our model and the sheets within, let's move on to the next step, where we identify the required data structures, functions, and cell reference types. With an appropriate model design in place, we need to now analyze the layouts of our data preparation sheet and determine an appropriate hierarchy for our naming convention, identify the required inputs and any constraints required for data entry, leverage our Excel skills to select appropriate data structures for accessing and processing our data, and also determine how our formulas may be copied, moved, or filled within our model so we can include appropriate cell reference types. Now let's review these items in detail. The content on our prep budget sheet can be broken down into multiple columnar groups. These include categories, actuals, budget, forecast, budget variation, and finally, calculated budget. We can further break down these logical groups into another hierarchical level referenced by our Level 2 column headers. For example, budget year for calculated budget, base metric, base value, percent change, and dollar change for budget variation, current year for forecast, and so on. Similarly, the content can also be divided into horizontal groups for revenues and operating expenses. So with this structure in mind, we can define our naming convention using the following acronyms for our Level 1 column headers and names for our Level 2 column headers. We can also use the Rev and OPEX codes for our horizontal groups. So when naming specific items within our content, we can use the following syntax: the sheet acronym PB followed by an underscore, then the acronym for our Level 1 column header, which is A in this case for actuals, followed by another underscore, then the data structure prefix like range or spill, followed by our Level 2 column header, which in this case is 2 years ago. Finally, we can add the Rev or OPEX suffix to the name in order to identify the specific horizontal group for this object. For consistency, we can easily use this name for similar items within another horizontal group. For that, we just need to change the suffix for the new name as relevant to the new horizontal group. For cases where the defined name spans across multiple columnar groups, for example, the totals rows, we can skip the columnar group acronym within the name and continue with the rest of the syntax. These names can still be copied across other horizontal groups by just changing the suffix, or when required, by changing the data structure prefix in addition to the suffix for our name. Please note that within this naming syntax, we could have swapped the locations for our Level 1 column header acronym and the suffix for the relevant horizontal group. However, it is usually better to have the higher group counts within the hierarchical section of our names as opposed to the suffix. This helps to have a better organization for our names, especially when reviewing names within the name manager list or using the autocomplete list when typing formulas. Next, let's look at the required inputs for this sheet and any data entry constraints that we might need to include. For the calculations on this specific sheet, we will need some input variables as defined on the input sheet. These include the analysis date, current year, and the budget year. Users will also be able to enter the percent and dollar variances within columns M and N, which we can pre-format appropriately. As for the base metric dropdown, we have used Excel data validation to limit the responses and generate appropriate error messages in case of data entry errors. Now let's determine the appropriate data structures for this layout, which might identify additional inputs or define names that we will need for this sheet. To start with, let's look at the revenue and operating expense categories. With the latest versions of Excel 365, we have a couple of options here. We can either use a predefined manually enter list of categories, or we can use dynamic array formulas to automatically generate and update the relevant lists based on the source data. Since Emily's company maintains the latest copy of Excel 365, we will use dynamic array formulas for this model. Now let's mark this data structure within our model. Now since we have used a dynamic array formula for our categories on the left, we can author the formulas for other calculated values in the same row by referencing the spilled ranges for our categories. By doing so, we will effectively write dynamic array formulas for all calculations in this row. This will also maintain the same vertical sequence for the categories and their corresponding calculated values. So we can now mark these spilled ranges on our layout. Similarly, we can identify the spilled ranges for our operating expense data. In addition to these spilled ranges, we will probably need to define additional range names for the manually entered data within our rows. This would include the base metric, percent change, and dollar change fields on this sheet. Similar to the calculated values, we will need separate ranges within these columns for the revenue and operating expense categories. So with that, we have now identified most of our data structures for this sheet. Next, let's look at some expected functions and the copy, move, and fill patterns for our formulas. Since I have already reviewed our source data, I know that we will need to use the unique and filter functions for our category arrays on the left. We may also want to combine these functions with the sort function to list our categories in an alphabetical order. Next, our actuals and budget calculations will most likely use the SUMIFs function, as we need to aggregate the source data while filtering with the category spill range on the left and the corresponding year at the top. It is important to note that in this case, we will need to reference the spill range on the left using absolute cell references or defined names so that it doesn't change as formulas are copied down or across. Additionally, the year at the top will need to be referenced using a combination of absolute and relative cell references so that the column reference changes when the formulas are copied across, but the row reference does not change when the same formulas are copied down. Now let's record our expected function for the actuals and budget calculations. Moving further to the right, we will need some date functions for our forecast column, as we need to prorate our actuals for the number of days left in the year beyond our analysis date. The base value calculation will probably need to use the switch function as we qualify the selected base metric before returning an appropriate result. And finally, our calculated budget formula will use the logical if function to determine if the user has entered a dollar change value to then appropriately calculate the resulting budget value. Now, once we've authored all our calculations, we will probably define names for all spill ranges so they can be easily referenced for further analytics. We should also add defined names for all spill ranges created for the calculated values within each columnar group of our layout. This will ensure that our references do not get updated as formulas are copied across or down, and that the formulas are easy to author and support in the future. So with that, we now have a good understanding of our model design, data structures, and some key functions we want to use. Now let's use this information to start populating our model with the desired data. With the design finalized and the required data structures and key functions identified, we can now begin populating data within our model. Using the naming convention and structures from the previous sublesson, I've already defined the names required for this exercise. This will allow us to focus on other topics we haven't covered thus far. All predefined names use the standard naming convention we developed earlier in this lesson. So the names for the spill ranges within the actuals and budget sections start with the sheet acronym PB, followed by an underscore, then the section acronym, which is A or B, followed by another underscore, then our standard spill range prefix, SPL, followed by the corresponding level 2 column header, and finally the rev or OPEX suffix to identify the specific horizontal group for the range. Similarly, the names within our budget variation section will follow a consistent pattern by replacing the spill range prefix SPL with the RNG prefix for cell ranges that include manually entered data. This would apply for the following fields within this section: base metric, percentage change, and dollar change. And as we discussed earlier, the names for the totals rows do not include the section or columnar group reference since they span across multiple sections. So now, let's author the required formulas that will use these names and other inputs to prepare our data for analysis. We will start by first activating our formulas for the analysis date, current year, budget year, and the individual year references within our columnar sections. To do so, we just need to remove the single quote at the start of our formula expressions and press enter. Having done so for all such formulas, let's move on to the spill range for our revenue categories. We want to leverage our sales data for this dynamic array so we can capture all categories where we have sales. Having already reviewed our source data, I know that we need to use the product category field from our sales source data table. So we'll get all unique values from this column and then sort them in ascending order. As you can see, our formula resulted in a spill header. As we had discussed in the previous lessons, we can click on the formula cell to review the boundaries of our spill range and identify the cells that need to be cleared of all other content. So in this case, we'll add a couple extra lines below our formula cell for the spill to work. As our operating expense categories are not part of the same data set, we will need a slightly different approach for this list. Here, we need to use the account hierarchy levels defined within our account source data table. While our categories are stored in the account hierarchy level 4 column, we will need to filter on level 3 values to only get the categories for operating expenses. So let's use the filter function as our first step. Here, we want to get data from the account table, from our account hierarchy level 4 column, and we want to filter from the same table, the account hierarchy level 3 column, where the value is equal to operating expenses. We'll put an absolute reference for the operating expenses text, and then close our brackets and press enter. As you can see, we again get a spill error. This is probably because there's a long list of values returned from the level 4 column. Let's use the unique function again to limit the returned array. Now that we have our values returned, there's a couple of things we want to note. First, there's an empty value in this list, which we probably want to ignore for such scenarios. And also, we need to sort this list as well. So let's start by removing the empty value first. For the include criteria on the filter function, we can use a multiplication operator to create an AND logic. Here, we want to check for the values in the hierarchy level 4 column to be not blank. With the filter updated, we can also add the sort function to this expression. We can press enter to review our desired results. Moving on to the actual section for our revenues horizontal group, we need to now author a formula that aggregates the line total field of our sales table while filtering the results using the categories on the left and the year at the top. As discussed earlier, we'll be using the SUMIFs function here. For our sum range, we want to reference the sales table and the line total field within it. We want to filter by the product category field within the sales table. And the criteria for this field will be our spilled range for revenue categories. If you remember for previous lessons, we can use the spill reference notation, which is the pound symbol, to reference all values within this range. For the second criteria of the SUMIFs function, we'll be using the order year field to filter values corresponding to the current column's year. Here, we'll use a mix of absolute and relative cell references by pressing the F4 key twice. This cell reference will now update as we copy the formula across into other columns to the right. However, with the absolute reference for the row number, we will maintain a reference for row 7 as we copy this formula down into the operating expenses section. We can now press enter to review our results. Now here comes the interesting part. Since we've used an appropriate mix of absolute and relative cell references and defined names, we can simply copy this formula into the cell to the right for it to automatically update and provide the correct results. Similarly, we can move to the next cell on the right and simply use the Ctrl-R keyboard shortcut to copy the formula across. So with proper planning and adequate knowledge of cell reference types, it's that easy to author formulas at the end. Now let's use a similar approach to author our formulas for the operating expense actuals. Here, we'll need to aggregate the amount column of our spend table and provide criteria where the level 3 field is operating expenses The level 4 field is part of the categories on the left, again using the spill reference notation. And the expense here is equal to the year for this column. We can then press enter to confirm the results. Similar to the revenue section, we can copy this formula across for the other years. Now moving on to the budget section, we need to aggregate the amount column of our budget table where the scenario name is budget, which we've defined as an input variable on the input sheet. And the account hierarchy level 5 is gross sales. Now we could have defined this gross sales text on our input sheet similar to the scenario name as well, but for this example, we'll just continue with the string constant. Next, we want to check for hierarchy level 6 to be one of the category levels on the left. Finally, we'll check the year column for our budget table to be equal to the year of the current column. We'll close the brackets and press enter. As you'll notice, even for this complex formula, using a consistent naming convention and a decent structure for our formula code allows us to easily review and understand our formula. We'll now move to the cell on the right and copy this formula across for the current year budget. Now, because we're using the same budget data set for revenue and operating expenses, we can simply copy this formula into the operating expenses budget section. We then need to make a few minor adjustments to this formula for it to work correctly in this new context. We'll start by changing the hierarchy level column references to those that correspond to operating expenses. And then we'll change the gross sales text to the operating expenses reference. And finally, we'll change the spilled range reference to the operating expense categories. We'll then press enter to review the results and copy this formula across into the current year column. Now moving on to the forecast calculation, we'll start with the actuals for the current year. Use the spill reference notation for the entire range. And then add a prorated value for the budget amounts for the current year. We'll calculate our ratio by dividing the number of days left in the year by 365. Similar to the budget section, we can copy this formula into the operating expenses section below. We can then make a couple of modifications to the spilled range references and get our desired results. Next, we'll look at the base value calculation within the budget variation section. For this formula, I've already created a template using the switch function within Excel. Here, we're going to compare the selected base metric value on this row against some predefined options. These are the same options that are available in the drop-down for the base metric field. So now we'll individually go through these options and assign a corresponding result. For the options related to the current year budget, forecast, and previous year actuals, we can simply reference the corresponding spill ranges as results. And for the final option, we'll need to calculate the relevant average. Now, an important thing to note with this formula is that we've combined references for cell ranges and dynamic arrays. The only way this would be possible is if all ranges and dynamic arrays have the same dimensions. In our case, all of these data structures have a single column and 4 rows. Now let's enter this formula and copy it down into the operating expenses section. Again, we'll need to change some references for this formula to work correctly. With the formulas confirmed, let's enter some values to confirm our logic. We can also add some values for the operating expense section. Next, let's add some sample data for our percent change and dollar change columns. We will also remove some of these extra data entry cells before moving on to the calculated budget formula. For this final section, we can use the basic if function to first check if the dollar change value is 0, in which case we want to take our base value and add the percent radiation to it. However, if the dollar change value is not 0, we want to only add the specified dollar amount to our base value. We can again copy this formula into our operating expenses section and update the suffix for our defined names. So with all our calculated values now complete, let's author the formulas for our totals rows. Now, before we start authoring these formulas, it is important to realize that the totals row for both the revenue and operating expense sections is at the top for each data set. So a formula with the right mix of absolute and relative cell references can be easily copied across into other columns and down into the other section. So with that premise, let's look at the options for this formula. We will start in the actual section and look to sum the first spill range. As you can notice, Excel automatically populates the defined name for this starting cell. However, using defined names, we will not be able to update the formulas automatically when copied across or down into the different sections. We will thus replace this defined name with the relative reference for the starting cell. We will then use the spill reference notation and calculate the sum of the entire range. Since we have relative references for both the rows and columns in this formula, we can now easily copy this across and down into the different sections. As you can see, with the formula copied across and then down, it still references the desired range. With the totals row for the revenue and operating expenses sections now completed, let's look at our options for the net profit calculation. Now, net profit by definition is our revenues minus operating expenses. And since we've already defined names for the totals row within our revenue and operating expense sections, we could probably use those ranges to easily calculate the net profit for each column in our data set. However, in doing so, we probably want to skip columns where we have no data or where we have non-numeric data. So within our formula, we can check for the revenue total cell in this column to be blank. And if it is, we want to return a blank value. However, if it is not blank, we want to return the difference between our revenues and operating expenses. So clearly, this formula does not show any results for a column without any data or with non-numeric data. So the final bit of functionality that we want to add to this sheet is to highlight some results as per our original user requirements. To do so, we'll add some cell formatting for our net profit forecast, and then move on to apply conditional formatting for our forecast cells. If you remember, one of our user requirements was to highlight the variance between our forecast for current year and the corresponding budget for the current year. To do so, we'll go under the Home tab, then Conditional Formatting, highlight Cell Rules, and then select the Less Than option. Here, instead of entering a specific value, we'll select the first cell of our current year budget. We will then press F4 twice to set up a relative row reference. With this expression, Excel will compare each value within our forecast column to the corresponding value within our current year budget column, starting at the cell we just selected. Once confirmed, we can click on OK to accept the new formatting. Similarly, we can add additional formatting for values that are greater than our budget. Now, to copy this conditional formatting into the same column of our operating expense section, we can simply click on any cell, go under the Home tab, select the Format Painter button, and then click and drag to select all values within the same column of the operating expense section. In this case, however, we probably want to switch our two rules. For expenses, it probably makes sense to highlight a greater value in red and a reduced value in green. To make this change, we'll go under Home, Conditional Formatting, and then Manage Rules. Here, we can edit individual rules and change the operator to get the desired results. We can then click on OK to accept all changes. We can apply similar formatting to highlight the variance between our original budget and the calculated budget. Finally, we should apply some outlining to the revenue and operating expense sections of our layout for ease of navigation for the end user. To do so, we will select the rows that we want to collapse together, go to the Data tab, Outline, and then select the Group option. We'll do a similar configuration for the operating expense section. Once completed, we can individually collapse these sections to free up space for other information we may need to review. Okay, So with that, we have now sourced all data required for our model, designed appropriate layouts, and authored relevant formulas to process our data. I hope we have demonstrated how easily we were able to populate the data within our model due to the planning and design activities we had undertaken prior to this. Now to wrap up this lesson, let's look at implementing our final set of requirements related to summarizing results and highlighting data insights. Let's recap our user requirements for visuals and data insights. First, we were required to highlight the variance between budgets and forecast. We've already implemented this during the previous sub-lesson using conditional formatting. Now, we will create the other required visuals to provide a categorical breakdown for the current year actuals for revenues and expenses, a comparison between budget and forecast for the current year by category, a similar comparison for the actuals from last year and the forecast for the current year, and finally, a graphic comparing budgets for the previous, current, and next year. So with that, let's begin. As we've already discussed the layout for a report page earlier in this lesson, let's proceed with creating the required visuals. We'll start with the two line charts at the top, where we will summarize the budgets for the previous, current, and next year. So let's go to Insert, look for the line chart group, click on the line chart with markers, select the chart, go under Chart Design, and then select Data. Here, we'll remove the series that Excel has automatically added to the chart. We'll then start adding the data that we need. For the series name, we'll click on the year value for the previous year, and then the corresponding values that we want to show in this series. Click OK, add another series for the 2020 data, then go to Series Values, and then select the corresponding values. Click OK again, and then add one last time. Go back on our prep sheet, select the year for 2021, and the values for 2021. Then we click OK again. Finally, we'll edit the horizontal axis labels, go back to our prep sheet, and select our revenue categories. Then click OK. Now that we have our basic chart done, let's start formatting some of the options. We'll click on the plus sign, select a chart title. We've already got a legend. Let's click on a data table. Now we've got the legend as part of the data table, so we'll uncheck the legend and maybe turn off the grid lines. Next, we'll edit our chart title and then maybe change the font and size for it. So we'll say size 10, and then we want it in bold. For the last piece of formatting, we'll right-click on our vertical axis, go to Format Axis, and then change the display units to millions. Okay, so I think our chart is now presentable. So we'll click on the chart, press the Alt key, and then drag it to its location. Again, pressing the Alt key snaps the chart to the cell edges. We'll again press the Alt key and drag the corner for the chart and size it to the area we had allocated. Now, as you can see, there's not much space left for our plot area. So maybe let's increase the sizes for the space that we've allocated for these charts. To do that, we'll select the rows that we've got the charts in, and then right-click, go row height, and then provide a higher value. Let's say 22 in this case. So as expected, our chart has resized as we change the row height. This is made possible by one of the properties for the chart. To review this property, we can click on the chart, then go to the Options area, click on the Size and Properties tab, expand the Properties section, and review or change this property as required. The couple other options here allow us to enable or disable printing for this chart, and also to lock this chart as part of sheet protection. We'll cover this topic during a later lesson in this course. Next, we'll try to reuse this visual to create the second line chart for our operating expenses. So we'll select the chart, copy, and paste it to another cell. We'll go under Chart Design, click on Select Data, and then select the first series, click on Edit, and then Tab to select the series values, and now select the operating expenses. Select the next series, click Edit, go into the value selection, and then select the relevant operating expenses. Finally, we'll go to the 2021 section, select the operating expenses again, and then change the axis labels to the operating expense categories. And then click OK to accept the changes. Now we've got the operating expense data on this chart, but I think we can do a little bit better by formatting it. So let's click on the plus sign, turn off the data table because that's taking up too much space. And we probably need to add a legend now. So we'll select that and then click on the plus sign again to hide this menu. As a last step, we'll right click on the vertical axis, select Format Axis, and then change the major and minor units. There, I think that's a little bit more legible now. Now we'll select the chart and drag it to its allocated space. We'll press the Alt key again and snap it to the cell edges. Now before moving on to the next visual, let's update our chart title. Next, we'll look at a funnel chart for the current year actuals. We can again start with the previous budget chart, copy and paste into the new location, and then go under Chart Design, change chart type, and then select the funnel chart option. We also need to change the data for this chart, so we'll go to Chart Design, select Data, and here we can remove a couple of the series since we only need one here for the actuals for the current year. We'll edit the last remaining series, select the current year value from under the actual section, and then select the values for this series. We'll then click OK to accept the changes. Next, we'll hold down the Alt key to resize this chart and fit it into the allocated space. And we'll also change the title for this new chart. This time, I'll probably highlight that the funnel chart is a new option within Excel, and the formatting options are a bit limited. At the time of this recording, we cannot sort the series values in this chart, and Excel expects that these values are sorted in the source data. Additionally, the data labels can only be turned on or off, without much option to position them around the bars on this chart. So although it is a good option to compare the different values, the usability for this chart is limited by the constraints we just discussed. Now, we'll replicate this chart for our operating expense categories. After creating a copy of this chart, we go to Chart Design, select Data, and edit our series. We'll leave the series name as is, and then change the series values to our operating expense values. We'll then update the horizontal axis labels to the operating expense categories. Now, as you've probably noticed, having a well-designed layout on the prep sheet is helping to expedite the creation and enhance the reusability of our visuals. With these examples, we're again trying to highlight the importance of a well-thought-out design for our models. Now let's move on to the next combo chart for the current year budget and forecast. Once again, we can select the original budget line chart and replicate it for the new visual. We'll then hold down the Alt key and resize this chart to the allotted space. Next, we'll change the chart type to a combo chart and then update a couple of options for this visual. If you remember on our previous funnel chart, the series for actuals had the orange color. For consistency purposes, we should probably keep the same color for the actual series on this chart. And since we'll be using a line chart for this series, we'll change the chart type for our 2020 series to a 2D line. We will change the 2021 series to a clustered column chart so that we can use it for forecast and then compare to the budget, which will be the 2019 series. At this time, we should probably note down these options for the Select Data dialog box. Now let's go and update the data for this chart. So here we'll repurpose this series as per our notes from the previous dialog box. So we'll rename the 2019 series to Budget and then select the values for the current year. 2020 will become our actuals, and then 2021 will be our forecast. We can now click OK to accept the changes. So learning from our previous visuals, we can go in to the Chart Elements menu, disable the data table, and then enable the legend. We probably want to place the legend at the top of the chart. Click plus sign again to hide the menu. We'll then update the chart title and then maybe go back into the Chart Elements menu and add some data labels. Now, similar to the other visuals we created, we can easily replicate this chart for the operating expense categories. However, for the purposes of this example, we will skip this step and move on to our final chart, which is the bar chart for our last year actuals and current year forecast. For this visual, we'll create our chart from scratch. So we'll go to Insert and then select the bar chart option. Go to Chart Design, select Data, remove all our series, and then add a new series for last year actuals. Go to the prep sheet and select the values. Press OK, and then add another series for the current year forecast. Select the values from our prep sheet and then click OK. We'll also update the horizontal axis labels to the revenue categories and then click OK on the Select Data Source dialog to accept the changes. We'll now right-click on the horizontal axis button, select Format Axis, and then change the display unit to millions. We'll then also add a chart title and change it to an appropriate text. Now, one thing of note here is that our series colors are not consistent with the other charts that we've done. So we'll select the forecast series, go to the options area, select fill and line, And then under Fill, we'll select the red color that we'd previously selected for forecast. Next, we'll select the Actuals series, and then select the orange color for it. Finally, we'll hide the grid lines to be consistent with the other charts, and then move and resize our chart. You should now be able to easily replicate this chart for the operating expense categories. So once again, we will skip that step. Okay, with that, we have followed a step process to design and implement an efficient, reliable, and sustainable solution for Emily and her team. Our final product is relevant to the user requirements given to us and consists of reusable layouts, formulas, and visuals. The topics covered in this lesson should help you consistently deliver similar solutions for other clients. Next in this course, we will cover interactive reporting within Excel before learning to set up our Excel-based solutions for collaboration and distribution.
In this lesson, we will look at other mechanisms in Excel that can be used to enhance the decision-making and management process. As you've seen to this point, step 1 in analysis is first organizing your data into tables. Once your data is organized into tables, we can then use their features to help drive insights. These are the use of filtering, sorting, the totals row, and conditional formatting. In this lesson, we will look at different means to aggregate and summarize data. And then we will look at using visualizations to help tell stories that are designed to enable users to digest massive quantities of information quickly. These are questions such as, who is our best customer? Who consistently pays on time? What are our payroll costs over time? And can we determine if current payroll seems reasonable by comparing it to other periods? For this, we will look at using pivot tables, which are often considered the gold standard for measuring Excel knowledge. A pivot table is a powerful tool to calculate, summarize, and analyze data that lets you see comparisons, patterns, and trends in your data. In addition to that, Excel offers other functionality to enhance the data analysis capabilities. And here we will look at using pivot charts. In this lesson, we will cover the use of pivot tables, we'll review chart types, and we'll take a deeper look into pivot charts. Let's begin. As mentioned in the lesson overview, the first step in a lot of analytic endeavors is to first get your data organized into an Excel table and take advantage of some of the features and functions available in them. As we can see in this example here, we have a very basic Excel table that is listing off some orders that we have for our particular business. We can see over on the far right-hand side, we're taking advantage of some conditional formatting to show the line totals. We can see at the very bottom of the table, we have a totals row set up to show us the total for all of the line totals that are available. We can also then go through and sort our data set. So if I wanted to go and sort by the largest to smallest line totals like so, I could go ahead and do that. If I wanted to go ahead and sort my data set, or not sort it, to filter to only show maybe the sales that are in Australia, I can go ahead and do that. And everything goes ahead and reacts to what we had just chosen there. So this is really nice for doing some basic analytics. But what happens now if we actually want to start looking at much more deeper levels of aggregates? So that is where the pivot table is going to come in to help us aggregate this information a little bit better. So on this particular sheet, I have an Excel table that is very large. It has a number of rows of data in it. If I want to go down, I can take a look at, in particular, how many rows of data are in the actual file itself. So I can see that I have 46,647 rows in the actual file itself. So an awful lot of data. I wouldn't necessarily want to be using the same techniques I showed you previously here to go ahead and make some sense of this data here. This is where pivot tables are going to help out considerably in terms of digesting this information and aggregating things better and allowing us to maybe drill into lower levels of detail. So scenario number one is your manager comes to you and they want a summary of sales by product category. So what we want to do here first is let's go ahead and actually apply some of the naming conventions that we talked about a little bit earlier in the class here. And this sheet here is called sheet number one. Let's just double click this and we'll call this data. So we can see that our data is on this particular tab. If I have my mouse highlighted in the actual table itself, I can see my table design tab pops up. And this table is called table one. Let's actually give that a better name. Let's call this TBL sales data, like so. Go ahead and hit enter. And now what we want to do is go ahead and create a pivot table out of this. Now there are a lot of ways to go about creating this pivot table, so we'll just show you this one as a first method. So what we want to do here is go ahead and click on the Insert tab, and under the Tables group we can see here that we have this pivot table. There is the ability to recommend different pivot tables, but myself I always find it easier just to go ahead and choose the pivot table like so, and then build it how I see fit. So I'm going to go ahead and just click Pivot Table, and we can see that it has picked up on the fact that my mouse was inside of this table of data, and it asked me, do you want the table or range called TBL sales data? And this is one of the reasons why we really like to name our objects properly inside of Excel, so that we can more easily reference them and understand what we're picking up on when we're doing some subsequent work here. So what we'll do now is we're just going to click OK after we've actually made a selection here. We're going to put this into a brand new worksheet, and this being the pivot table. So click OK. And now we end up with this brand new sheet of data. So what we're going to call this is we're going to rename sheet one. We're just going to call this SHT pivot data, like so. Give that a proper name. And the second thing we're going to do is we're actually going to go and name this pivot table as well. So what we'll see here is if I put my cursor inside of this actual pivot table canvas right here and go up to the pivot table analyze tab, I'll see that this pivot table is actually called pivot table 2. Let's actually go ahead and name this to PVT, so for pivot, and call this sales data. So let's actually give this a proper name. So when I go ahead and do that, hit enter, we're going to see now that right here, right in here in the screen, that has now been renamed to PVT sales data as well. Now I'm going to go ahead and turn my grid lines off as well because I'm not a big fan of working with my grid lines, like so. And now let's start building that pivot table that our manager had asked us for. So what we're going to do first is we are going to go over to our pivot table fields and scroll down to the very bottom here and find the line total. And we're just going to click on line total and drag that into the values bucket right here. And what we're going to see right now is we end up with the sum of line total. Next, what we're going to do here is we're going to grab our product category from the fields list, so product category here, and we're going to drag it into the rows like so. Now, alternately, I could, if I wanted to, click the checkbox right next to product category like so, and it will also put the data in the rows like so. Okay, so this meets the requirements that our manager has brought to us. So you take it to the manager, they say, that's fantastic, I really like this, but I want to see that in a little different form. And that form happens to be, now I want to see this data over time. So what we're going to do here now is we are going to take the new requirement from our manager to make this data set show up over time and go ahead into our fields list here. And what we're going to do now is we're going to grab our order date. So I'm going to grab order date and drag it into the columns bucket here like so. And now we're going to see that we have our product categories by the different years with the line totals in here. So now we're further aggregating our data down to different levels so that we can traverse through the different levels to see what are all the different months within 2019 and quarters, and same thing in 2020, and actually drill down to all these different areas and better slice and dice our data than we could have in that Excel table that had in excess of 46,000 rows. Now you may notice that this pivot table isn't particularly visually appealing. We could use to format it a little bit nicer. but we're going to talk about that in subsequent lessons. But before we do that, let's actually just do a quick tour of the different regions of our pivot table. So what we can do is, if our cursor is inside of the actual pivot table itself, we're going to once again see we have this pivot table analyze tab. And over on the far right, under this show group, we have a number of different buttons that we can go ahead and click. So these different buttons here are this. If I click the field list, we'll notice down below here that this pivot table fields pane is going to disappear. So if I click this and give it a sec here, it disappears. And if I click it again, we'll notice it reappears. If I click this plus minus buttons, you'll notice over here in the pivot table, these plus and minus symbols will disappear. So now the data is not drillable. Click on that. And then if I click on this field headers, you're going to notice that these two headers here will actually disappear. So the column labels and row labels will disappear as well, like so. And there we go. So there's a few different things we can do to our pivot table from a visual perspective to at least show some different things. But let's actually walk through the different parts of the actual pivot table itself. So over here is the actual pivot table. So right in here, if we go ahead and choose that, that is our pivot table. If we want, we can go ahead and continue to add to our pivot table. And we do that by going into the fields list, which is right here. So we can see all the different fields that are part of this particular pivot table. And the ones that are currently in use are in bold here and have a check mark next to them. If I had a very large list of fields in my table, I could actually go ahead and use this search bar to go ahead and find the columns I want, like so. And then down below, as we've already started interacting with, we have our columns area. So here's where we can put all the different fields that we want on the columns, all the different fields we want on rows, the fields we want to put on the filters that are particular to this particular pivot table. Or I can actually go ahead and put things down here in the values area. And these are typically things you want to sum, average, min, max, or count. So these are generally our numeric values. You also down below here have the ability to defer the layout of the pivot table, which is really nice if you have a very large data set and you want to move things into the rows and columns and values and maybe even the filters, but you don't want the pivot table to continuously refresh. It can tend to slow things down a little bit if you have a really large data set. So you can click on that defer layout and then just click this button over here called update, which actually allows you to update only when you see fit. I'd say for the most part, I have that box unchecked because the data sets I'm working with on the machines I typically work with aren't usually that big a deal to let just refresh as we're actually going ahead and building things up. And the last thing we wanted to point out, so in addition to when you have the pivot table highlighted, having this pivot table analyze tab, which we've already started interacting with some of the functions in there, we also have the design tab. So we are going to spend some subsequent sub-lessons going through each one of these different tabs and their various functions and features to show you the different things you can do with your pivot table. We've completed our basic pivot table, which we did back in the previous sub-lesson, and now we want to look to interact more with the existing pivot table we have created. So what we're going to do here is we're going to put our mouse inside of the actual pivot table so that our pivot table's fields list pops up. And now what we want to do here is look to put some additional information inside of the pivot table. So what we're going to do here is we are going to grab our product categories. So we're going to go ahead and find the product category. And we see that it is already in there. And what we want to do is go ahead and add in the sales territories above it. So I'm going to go in and grab my sales territories and put it right above the rows. So as I'm getting ready to drop it in the rows area, I can see that just as I get in, if I'm right above the product category, a little green line shows up and I can see that I can actually drop my field in there. And now I get a breakdown that looks something like this right here. So we can add multiple fields to the filters, rows, columns, and values, and we're going to see that over the next little bit here. Next, what we're going to do is we're going to go and grab our order type. So we're going to go here and find the order type. And I can see that searching through this list is a little bit of a pain given that it is not in alphabetical order. So right now the list is actually sitting in the order that the data came in the source. If I want, I can actually go up here into my pivot table tools, click on this, and show the sorting in A to Z like so. So this way now, if I want to go and find a column like my order type, I can actually go to the O's because it's in alphabetical order and go to here and drag it into the filters like so. That just makes the navigation a little bit easier, I find. Okay, so now that we've added the order type in, what we want to do here is we are going to go to the pivot table, and under the drop-down box, we are going to choose the online orders. So I'm going to go here and filter this pivot table down to online orders. And now we're going to see it react to that particular filter. And now let's go ahead and add a filter on our territory. So what I can do is go over here and click on this drop-down box right here. And now what I want to do is I'm just going to choose Canada and Australia. So I'm just going to click the select all, go Australia, Canada, click OK. And now my pivot table is showing me the sales territories of Australia and Canada for the online order types. So I can continue to interact with this in different ways. So I've gone through and I've completed that filtering, but what if I wanted to go ahead and get rid of all the filters, that I've actually applied to my data set? So let's go back over to my pivot table here. And with my mouse inside of the actual pivot table, I can go up to my pivot table analyze tab, and under actions, I can choose clear here and say clear filters. So if I want to clear all the filters right now that are set for this particular pivot table, I can click on that. And now we get back to the unfiltered state for that particular pivot table. Okay, so what we are going to do next here is I'm going to remove the sales territory from the rows. So I'm just going to go over here, and to do that I can click on it and say remove field like so, or what I can do is click on it and drag it into the middle, and we'll see that it turns as a red X. Or I could have actually gone up here into the fields list and just simply unchecked the box there. So there's a number of different ways to get rid of the fields that you may choose to. So next, what we're going to do here now is we are going to go in and we're going to take our order quantity and we are going to drop it into the values. So I'm going to go ahead and find my order quantity field like so, drop it into values. And now we can see that I have multiple different aggregations that I can place in here, and they're showing up on the actual pivot chart. So I can see for 2019, I've got the sum of line total here and the sum of order quantity all or both paired together in 2019, and then the same thing in 2020. So we do have the ability here, if I just make this a little bit larger here, we can see that when I drop the sum of order quantity into the values, it actually put a values indicator up here in the columns. I could take that and move it up above the actual other values here. So we can see now my pivot table adjusts to actually show the sum of line and then the two different years down below, sum of order quantity, the 2 years down below. I could actually take this values and move it down over here to the product categories if I want to show it like that. So there's a few different places where I can go and actually move this to. But what I'm going to do here is I'm just going to put it back to its default location under the category. So I'm just going to take this and move it over here and set my pivot table like so. And that brings an end to this sublesson. So far, we have been taking advantage of a pivot table to summarize and aggregate data. But at this point, things really haven't looked that nice from a presentation perspective. In this sublesson, we're going to talk about how to lay out a pivot table for a little bit better reporting presentation. What we're going to focus on here is how to actually lay this report out. So by default, let's just go ahead and put our cursor inside the pivot table first. And we're going to go up into the tabs here and click on the Design tab. And if we move over to the Layout area, we can see there's a number of different layout options we have here. So what we're going to do is click on this report layout and take a look at our different options. Right now, the default format or layout for a pivot table in the newer versions of Excel is the compact form. And if I just move outside here, we can see that we have the different nesting all right within one column. So if I click on column A, we can see that we have our sales territories and our product categories all nested into one column, which may look nice from a printing perspective, but maybe you want to actually have these values down here, the nested ones, off in different columns, in which case the other layout options may be preferable for you. So let's go ahead and take a look. Okay, so once again, click inside the pivot table. We want to go up to the Design tab, and now let's move over to the Report Layout section. So what we're going to do here is we are going to choose the outline form for this. So click on Outline, and now we are going to see that we have the pivot table showing up so that the sales territories are in one column, so column A, and the product categories, opposed to being nested underneath sales territories in column A, are actually out in their own column now. All right, so now let's go and take a look at the other layout here. So I'm going to once again click back inside the pivot table, go back up to Design, go to my Report Layout, and now I'm going to choose Tabular Format. And we'll notice that it is very similar, other than the fact that the blank row at the very top has been removed. So we can see that the sales territories are in column A, product categories are in column B, and everything's separated off into their own columns now. And with this particular layout here, we can see that the totals show up on the very bottom, and they show up on the very bottom only. Back over in the previous outline, so if we just go back to the one we had looked at previously here, the outline form, if I click on that, we'll notice that we have this little blank row right here at the top where we can have our subtotals here, or we can move them down below, and we'll show you how to do that momentarily. So before we do that, just to recap, there's the three different layout forms. There's the compact form, which is the default form for setting up our pivot tables. There's the tabular form, which displays one column per field and provides space for field headers. Then there's the outline form, which is similar to the tabular form, but it can also display subtotals at the top of every row or the bottom, because we have the space at the very top of the pivot table there. So leaving it here on the outline form, I can go back over to my Design tab, and under Report Layouts, I have a couple more options. I can say repeat all item labels, which they already all are, or I can say do not repeat item labels. So in this case here, I'm going to choose do not repeat item labels, and we'll notice that for the sales territories there were Australia and Canada and all the sales territories repeating themselves over and over again, this will disappear. So I go ahead and click like that, and now we have a little bit cleaner look. If I wanted to put them back, I could just go to Report Layout, say the repeat all item labels, but I'm going to leave it like this. In addition, I have the ability to go over to the blank rows section here, and if I want, I can insert a blank line after each item. So we'll notice that after the break of each one of these sales territories, that we get a blank line here. Or if I want, I can actually go ahead and remove that. So I have a couple different layout options there as well. So further touring through some of our layout options, we have the ability over on the left here to take a look at our subtotals and grand totals. So here under subtotals, I could choose to not show the subtotals at all. So we can see where the subtotals are before I do that at the very top here. I can go over to subtotals and say do not show them. So that removes the subtotals. I can ask to show the subtotals at the bottom of the group. So I can have them at the bottom. Or I can put them back where they were when I first started and actually have them at the very top. So a few different things we can do with the subtotals. And then same things with the grand totals here. I can turn them off for the rows and columns. So if I go down below here, you're going to see that the grand totals are off at the very bottom here. I can say on for rows, which is doing nothing. I can say on for columns, which will put the grand totals back here. And those other ones would work if I had some grand totals that were to the right or right-hand side here. And once again, I can go over here and say put them back on for rows and columns, which is basically where I was before. So now I got my grand total at the very bottom. So I can play around with, once again, just to recap the different layouts here. I can have the repeating of the item labels. I can insert blank rows between each one of the items. And I can toggle the subtotals and grand totals on and off as I see fit. Okay, so that is it for the layout section here, and that brings an end to this sublesson. In this sublesson, we're going to talk about a number of things we can do to format our pivot tables. Let's begin. Okay, so what we are going to do first is we are going to go into the values area of the pivot table that we have open, and we can see that we have a column here called sum of order quantity. And what we want to do here is we are going to click the box next to it here, like so, and we're going to go into the value field setting so that we end up with the value settings dialogs box like so. What we're going to do now is we want to actually first go and give the field a good custom name, something better than what was given by default. So what we're going to do here is we're going to say total order quantity, like so. And we also want to take a look at what the source name is. So we can see the source name out of the pivot fields list is order quantity. So we know where that is actually coming from. So that is the name that we're going to give as a custom field. So we're going to then go and take a look at the different ways that we can summarize our values by. So in this case, the default is sum, which is what we wanted to choose. And we can notice here, just by accidentally clicking this, that I went and lost the custom name that I gave to my particular report. So I'm just going to go back over and take the value here and put that back into the field here like it was a moment ago. So I can go through, I'm going to leave those summarized fields alone momentarily. But what I want to do here is I'm going to go in and now give my number a format. So my total order quantity, if I click on number format here, I can go and choose a number of different formats. So I'm going to go from general, I'm going to change this to number. I'm going to knock my decimal points down to 2. I'm going to ask it to use the thousandths separator, and I want my negative numbers to show up with a negative in front and as a red number. So once I've got all that, I can click OK, and that is going to format my number before we go ahead and display it. And what we can also do here is take a look at a couple other ways to show the values based on other values and calculations we've chosen in the table. We're going to do that next here. So we're going to come back to this tab in a moment. We're going to right now save this total order quantity custom name and the number formatting we did like so. So we're going to do that. We're going to notice the label up here changed to total order quantity, as did it down in the values area. Next thing we're going to do is we are going to go and re-bring the order quantity into the actual values pane. So I'm going to go and drag order quantity in here again, like so. So I'm just going to go like this and put it down in the values area, like so. But what we want to do here is we want to go and do some relative calculations instead. So I'm going to click on the sum of order quantity that just got dropped into the values field and say value field setting. And this time what I'm going to do is I'm going to give this a custom name of % of grand total, like so. And what I'm then going to do is I'm going to go over to the Show Values As tab, and I'm going to choose a calculation here and say % of grand total. All right, so I've got my field chosen properly there now. And we can go ahead and click OK. And we can now see that we have a total order quantity and the percentage of the grand total. And if we now just scroll through each one of these grand totals, we can see that this number right here, this 3.83%, is a certain percentage of this grand total down below. So the grand total for all. And we can go ahead and take a look at that at a couple different levels. We can look at it at the product category level, or we can look at it at the sales territory level as well. So we can then work our way back up to the top of the pivot table here and see now we've got our total order quantity, which we did first, and then now we have our percentage of grand total. Okay, so next let's take a look at row and column field settings. So we took a look at some field settings we could do at the values area, but now what about the rows and columns? So I'm going to get my mouse back into my pivot table, And now let's go ahead and take a look at the rows over here in the pivot table area itself. So what I'm going to do here is go down to the sales territory level. I'm going to click on this right here, and I'm going to once again say field settings. And a couple things that we can do here first is let's go ahead and rename the custom name to sales space territory so that it looks a little nicer on our reporting. And then what we're going to do is we are going to take a look at some of the other configuration settings that we can do here as well. We can see that in the subtotals and filters section that we can allow for automatic subtotals. We can say we want none. So I'm just going to choose none and click OK. So we can see the subtotals now disappear. Let's go ahead and put those back. So I'll go back over here, go to field settings and say automatic. Or what we're going to do next here is we could then go in and say custom. So I'm going to go ahead and choose custom. And what I'm going to do here is actually show you that I have the ability to actually add in 2 different subtotals. So I'm going to go in here and choose sum. And with the control key down, I'm going to click on average. So I'm going to pick 2 here now. And then go ahead and click OK. So we can see now that we have the sum of the order quantity here, and then right down below we have the average on each one of the actual orders itself. So we can actually put 2 summarizations on there, which is quite handy. So just some other configurations of interest here in the sales territory. So I'm just going to go ahead and open this one back up here, click on field settings, and over in the layout and print, I can change the layout of the actual pivot table itself. And recall, we did that back in one of the previous sub-lessons. We're going to leave this in tabular form. We can ask to repeat the item labels if we want. So let's go ahead and show you what that looks like. And if we had any data in here or categories that had no data, we could say, let's show the items with no data. And we're going to do a demo of that a little later on here in this particular section, just in a moment or two here. So I'm going to leave the repeat item labels on like so, and we're going to see the item labels repeat. And let's just go ahead and turn that back off here. So back in the field settings, go to layout and print, and click on the repeat item labels so we don't get those repeating again. Let's go ahead and go like that. And now we have our pivot table back to where we had it a moment ago. So lastly, what we're going to do here in this formatting of the pivot tables, we're going to go to the product category down the row section. I'm going to click on this and say field settings again. And let's go ahead and put a space between product and category just to make this look a little nicer from a reporting perspective. And we are going to do a couple of things to the data in here to show you some of the other configuration features that we can do as well. So I'm just going to click OK. So now we have product space category here on the pivot table itself. But what I'm going to do now is I'm going to go over my sales data here. And let's just go down the bottom of the pivot table first, actually. We can see that we have all of the entries in here for the sales territories, and we stop at United Kingdom. So what I'm going to do here is I'm going to go to the sales data, and I'm going to go in here, and I'm going to change this very first row and just change it to a different country name that doesn't exist. So I'm going to call this Bulgaria, like so. Go ahead and enter that in. And I'm going to go back over to my pivot table now. And what I'm going to do here is I'm going to go to the Data tab and say Refresh. I'm going to go ahead and refresh this pivot table. And now we can see that we get a entry in here for Bulgaria bikes. And it looks like it is pulling in a sum of 1 and an average of 1 here. So if I go in and take a look at the sales data for that, we'd see that that actually validates to what we had on the screen there. So let's go back over to my pivot table here really quick. And what we can see here is we only have bikes showing up. And we can see these other sales territories have multiple different product categories. So we have accessories, bikes, clothing, components. What if we wanted to actually show all of those here? So we can go ahead and do that. So I'm going to go over to the product category and go to field settings and go over to layout and print. And now what I'm going to do is say show items with no data. So I click on that, go OK. And now we're going to notice that we have accessories, clothing, and components showing up with no entries in here. So we've successfully now got all the categories showing up down in Bulgaria. But now what about these cells that have no entries in here? Well, what we can do is go to the pivot table level. So what I can do is with the mouse inside of the pivot table itself, I get the pivot table analyze tab up top here. I can go over to options and click on options here. And what we're going to do here is in the layout and format tab is there's a selection box here, a checkbox says for empty rows show, and it says nothing. So if I want, I can actually put a 0 in there or whatever value I decide to put, and I can go like that. And now I get those values showing up by default. So those are just a couple different things that we can do to this data here to allow for some additional formatting here. What I'm going to do is go back over to my sales data here, and I'm going to change this back to Germany, like so. And what I'm going to do is go back over to my pivot table, and I'm going to go to data and say refresh again. And now we'll notice that Bulgaria and all of its entries disappear from the pivot table itself. Okay, so that is a few of the different things you can do to format your pivot table within the values area and the rows area. And you can do similar things in the columns area as well. But it is essentially just a repetition of what we did back down in the rows area. So with that, that brings the end to this particular sublesson. In this sublesson, we're simply going to review some pivot table commands that may be of interest to you. All right, so let's begin by going into the pivot table itself, so making sure the pivot table, the cursor is focused inside the pivot table. We can see the pivot table analyze tab, so I've already got that highlighted here. And let's go over some of the different groups of functions that we have available to us here. So let's start first in the actions group. If we want, we can go in and take a look first at the select one. So we'll go in the middle here, and we can go in and enable ourselves to go in and select the entire pivot table if we want. So we can go ahead and click on the entire pivot table. We're going to notice now that the whole thing has been highlighted, and this is pretty handy if you have a very large pivot table and you want to go ahead and move it. So now that we have got the pivot table selected here, so let's just go back over here and choose the select again. So choose the entire pivot table. If I wanted to, I could click on this move here to take this pivot table and move it to, perhaps a new sheet or a new location. Let's just leave it on the exact same sheet, but maybe we just want to move it over to a different location. Maybe we're just going to stick this over in over here in B. Let's just put it over here in B5, something like that. Click that, and now we're going to notice the pivot table has moved. So we've shown you two of the functions there in the actual actions group. So click back there. Showed you how to go ahead and select the entire pivot table itself and then move the table. Over here in the clear section, we have a couple different things we can do. Is we've got a clear all and the clear filters. So there's a couple different reasons why we have these different selections here. Is the clear all resets your pivot table in any fields you've brought into the filters, rows, columns, or values, and they get completely removed. It doesn't delete your data or the link to the data, it just simply returns to a blank canvas. And if we have a pivot chart associated with this pivot table, clear all also removes the related pivot chart fields. So if I want, I could go ahead and click clear all, and we'll notice that I get myself back down to a blank canvas like so. What we can also show you here is this has been done through a couple of the sublessons, but worth showing again here now that we have a live example is the pivot table. I have the mouse inside the pivot table here, but the fields list isn't showing. So I can go back up to the show group here and I can click on fields list, and that will bring the fields list back into focus as well if I wanted to go ahead and play around with it. So what I'm going to do here is I'm just going to reset the pivot table back just by clicking the undo button here. And let's go and actually set a couple of filters on this pivot table. So I'm just going to go and just randomly uncheck salesperson like so, and in the rows label, I'm just going to choose Australia and Canada, something along those lines there. So now my pivot table looks like that. And if I wanted to wholesale clear the filters on this pivot table, right now it won't be that hard to go through each one of these drop-down boxes here, but what if we had a lot of different filters, or maybe even these two seem like a bit of a pain to go and get cleared out. So what I can do is with the pivot table focused again, I can go to clear and say clear filters, and that will get rid of the filters on my actual pivot table. All right, so moving a little over to the left, so we've covered everything in the actions group, what about the data group here? So we can go into the pivot table itself and we can change the data source for the pivot table. So if I click on change data source, we're going to see what the source is. We can see right now it's just using table 1, which is over on my sales data tab. I'm going to leave it alone for now because I don't have another data source to change it to, but if I wanted to give it a different source, I could go ahead and change it right here. So go ahead and click cancel there. Go back up to my pivot table analyze. And if I wanted to refresh this pivot table, either the single one that I'm highlighted on right now, I can click refresh, or if I had multiple pivot tables, I could click refresh all on all of those as well. So to show you what that'll do here, and we've done this back in some previous sub-lessons, but let's just once again show you the example. I'm going to go down to the bottom of the pivot table. I'm going to go over to my sales data here, and I'm just going to change Germany here to Bulgaria. Get her spelled right. Perfect. So go like that. And now I've changed the data at source to a different value. So I'm going to go back to my pivot table here. And if I go to my pivot table analyze and say refresh, and choose refresh here, now we're going to see the entry now comes from that data table in the form of Bulgaria, which we just modified before. So I'm going to go back over to my sales tab here and just change this back to Germany, like so. And then go back over to my pivot table and refresh my data. And click refresh, and now we'll notice Bulgaria disappears from my pivot table. All right, so going a little more to the left here, let's take a look at the pivot table group right here. So a couple things we can do in here is we can change the name of the pivot table. So I'm not really a big fan of this one here. Maybe I want to give this pivot table a proper name, and I'm going to say pivot. Let's say, what is this? Order quantity, by sales territory or something like that. Let's just go ahead and make it nice and simple. The big thing is making sure we give it a name that's meaningful when we want to come back to things later on and reference it, especially when we start getting into using slicers and timelines. So we want to give it a good name. We can also, under the pivot tables group, click on this options tab here and take a look at a couple of the things we can do to the pivot table itself. Now, as we go through this options dialog box here, there's a lot of things that we've already seen in other locations when configuring the pivot table. So, going through and taking a look at the totals and filters. So if I want to turn off or show the grand totals for the rows, show the grand totals for the columns, this one's already on. If I wanted to turn it off, I could do it here. And keep in mind, we could have done this, a number of these things out on the design tab under the format of the actual report itself. So we have the ability to play around with this. We can allow for multiple filters per field. On the layout and formatting, which we were just on, we could go ahead and, if there's any empty cells in our pivot table, so we can see it looks like the components for France right here has an empty value here, so I could go in and put a 0 here at the pivot table level, click OK, and now we'll see that zeros are getting placed wherever there was no value. So that's a handy one as well. So we can go back up over here. So we've talked about that one. We can go ahead and printing. So there's some things we can do for allowing us to expand and collapse the buttons when this is displayed on the pivot table for printing. Under the data tab here, we can ask that the data is refreshed when the file is opened. That's usually one of the biggest ones there. So we have some alt text we can put on the pivot table here, which is going to help with accessibility later on once we move into some subsequent sub-lessons. And finally, under the display tabs, let's click over here. We can allow us to show the expand collapse button. So I can click on this. It'll allow these plus and minus boxes to disappear. So let's just go ahead and do that. Click there. Go down here. We can notice that they disappear. We could also change it up here in the show group of the pivot table analyze. So once again, there's a lot of things that we can do in multiple different places. We can turn the contextual tooltips off. If we want to show the values row, and over here in the fields list, what we can do is we can actually have it sort in the data source order or sort in alphabetical order, which once again, we could have actually changed over here in the pivot tables list as well. So let's just go ahead and change that one. That's the last thing we're going to do here in this particular sub-lesson. So let's go ahead and say in our fields list, we want that to sort from A to Z. Click like that, and now we'll notice the fields list has modified itself to make it a little bit easier to find the fields, because now they're sorted in alphabetical order, not what they were back at source. Okay, so with that, that brings us to the end of this particular sublesson. Users do not often want to see an entire data set and are usually interested in smaller, more focused slices of data. You can narrow the data in a pivot table based on criteria that has been set by applying filters. In this sublesson, we will go through filtering data in the pivot table, which includes the label filters, value filters, and the manual selection filter. Let's start with the label filters, which are triggered by text-based criteria. So what we're going to do first here is within the pivot table, we're going to click the drop-down arrow next to sales territory. So let's go over here to the sales territory, click this drop-down box right here, and we will see a dialog box that we can interact with. So what we're going to do in here is just go down to the label filters, because that's what we're going to take a look at first. And we can see that on the context menu here that there are a number of different ways that we can do our label filters. We can do equals, does not equal, begins with, so picking things that begin with a certain character, text that does not begin with a certain character, text that ends with a certain character, that does not end with a certain character, and the list goes on. So you can just go through the rest of these particular options. So what we're going to do first is we're going to go choose greater than. So keeping in mind we were selected on the sales territory, we're going to say greater than, and we get prompted with a dialog box that we can interact with here. And what we're going to do is we're going to go in here and type the letter D. So I'm just going to go in and type D and go OK. So what this is going to do is get us all the labels that are greater than D. So we're going to notice that Australia and Canada dropped off from our data set. And then to go ahead and clear the filter after we've done that, we're just going to click on the filter box there and say clear filter from sales territory. So in these examples here, we're going to go through one by one and clear the filters as we go ahead and apply them. Keep in mind earlier on in the previous sublessons, we went through and showed you how in the pivot table, when you're selected inside the pivot table, the ability to go in here and clear all the filters that are applied to the pivot table at any given time. Right now, we're just going through one by one, so there's really no point going back up through here, and we'll just toggle them down here. So just keep that in mind as you're working with your pivot tables. So I guess it's time to actually clear that filter as opposed to just talking about it. So let's go ahead and clear that. And we'll notice that Australia, Canada, and I guess Central came back as well. So that's one that I missed there in the original one that we spoke of. So where we're going to go next here is we are going to go to the sales territory again, and we're going to click on this here. And what we're going to do is go to our label filters, and we are going to say begins with. So let's go over here and choose begins with. And if we want, we can say, let's say the letter N. So I think that's what we want to choose here, is choose N. So we can see that we have the Northeast sales territory and the Northwest sales territory up here. Okay, so let's go ahead and clear that one. So clear the filter out. And the last one we want to show here is we're going to the label filters once again. And this time what we're going to do is we're going to show you some of the search options here. So we're going to go to equals. And what we're going to talk about here is the use of the question mark to represent any single character, or the use of the asterisk to represent any series of characters. So what we want to do here in this particular example is we want to find any of the countries that have the letter E as the second character. So what we're going to do here is to do that, we're going to put the question mark to represent a single character. Then we're going to put the letter E. And then if we want to have any character with anything after E, we're just going to put the star there. What that's going to tell us to do is any character can show up in the first position, E has to be in the second, and then anything can show up after that. So let's just go ahead and choose that. And we end up with Central and Germany, because these are the only two sales territories with the letter E in the second position. So what I'm going to do here, again, is go back for my label filters. Let's go over here to equals, and let's go ahead and change this. So now let's go and assume that we want to go and filter our data so that we have the ability to have E anywhere in the actual character, so or the string. So what I can do there is I can go star E star, go like this, and now we will see all the sales territories that have the letter E anywhere in there. So let me just pop that back up here under the label filters. We just went to the equals and put star E star, and this would be equivalent to going over to this over here. So I'm just going to quickly clear this, and if I go back down to the label filters and says contains, I can go over here and put the letter E in here, and if it contains the E, we're going to end up with the same results, because that contains is actually letting me go and choose anything that contains the letter E. Okay, so next what we're going to do here is we're going to take a look at the value filters. So I'm just going to go and clear my filter from this here. And what we're going to do with the value filters are they're going to be triggered by value-based criteria. And it's important with these filters here to understand which level you're applying the filter at. So what I'm going to do here first is I'm going to go to my sales territories, and what I'm going to do is apply the filter at the sales territory level first. And to do that, I am going to go to the drop-down box right here, and instead of choosing label, I'm going to go down to value. And what I'm going to do here is I want to find all of the grand totals for sales territories that are between 8 and 10,000. So before I go ahead and do that, that is looking for any of the grand totals here at this level that are between $8 and $10,000. So don't look at the values in here because that's at the product category level. We are going to be concerned with the filter being applied here. So let's go ahead and do that. So go back over to this, go to the values and say between, and we're going to say the total order quantity because that's the item we want to take a look at because that's the only thing we have over in the values at the moment. And I'm going to say between 8,000. So let's go over here. Oops. Go ahead and type in 8,000 and 10,000, like so. And now we'll see that these are the two sales territories that fell between that particular range. So what we'll do now is we are going to go in here and we're going to clear that filter. Now we're going to apply the filters at the product category level. So let's go ahead and clear that out like so. And now what we're going to do is go into the product categories here. And keeping in mind, this time our filter is going to be applied here. So what I'm going to do is I'm going to choose the product category, go down to values filter, say between. And in this case, I want to see all the total order quantities that are between 1,000 and 2,000. So just go 1,000 and 2,000, like so. And you can visually take a look at some of the values here. We've got a couple that we can see on screen that are going to show up. So it's 1598. Nothing in this, nothing in Canada will show up. We've got a few values in here. So we've got 3 within the central region. So let's just go ahead and click OK. So we've got the value that showed up in Australia, the 3 which we just pointed out in the central region, and we can go through the rest of the ones down below here. So just be aware of which level you're providing the value filters at. So once again, we will go and clear this filter out like so. And the last filter that we want to show you is a top function. To go and either find the top of a range or the bottom range. And there's a couple different configurations we can put on that. So let's go over that right now. Okay, so let's take a look at the top filter. So what I'm going to do here is I'm going to go to sales territories, click the drop down box here, go to the value filter, and down at the bottom here, it's called the top 10. So that's just the name of it here, top 10. You have the ability to go in and configure this in a moment to either the top or bottom, and it doesn't even have to be the number 10. So it's just a way to do the top or bottom of a set of data. Okay, so let's go ahead and keep this first example nice and simple. So what we're going to do here is we're going to take a look at the top 3. So I'm going to change that from 10, which is default. The top 3 items by total order quantity. So what that's going to do is here, go in and take a look at the grand totals, which we have right here, and go and find the top 3 grand totals. So I'll go ahead and click OK. And we're going to see that we get these particular values right here. They're not in sorted order here by grand total, and we'll show you how to do sorting in a few moments here in this particular sub lesson. But for now, this goes and picks the top 3 items. So next what we'll do is let's go ahead and go back to the value filters, and I'm going to go back down to top 10. And this time what we're going to do here is we're going to change this from items to percent. So first what I need to do here is actually let's cancel this out, because I want to go and show you what this is doing here, because these next two are a little tricky to get your head wrapped around, but after you see a couple examples, they're pretty straightforward. So I'm just going to clear the filter there. We get down to the very bottom here, and the grand total for this particular data set here is 97,942. So if I ask for the top 10% of the data, what that's going to do is look for the groupings that are at least $9,736-ish for that particular grouping. So let's go ahead and do that. So I'm going to go up to the sales territory, go to my values filter, go to top 10. I'm going to go and ask for the top 10%, like so. Go ahead and click OK. And we're going to see that this is the top item that covers at least 10% of the actual sales. Okay, so that covers 10% of the data, but what if we wanted to actually take a look at 20% of the data? So what we're going to do in that particular instance is I'm going to go back over to my filter here, click the drop-down box, go to the value filter, top 10, and this time I'm going to say I want the top 20%. Now, 20%, just for some quick math that I already done on a sheet of paper, is $19,472. Now, we can already see that this one right here, which was the top, is only $19,180. So this isn't going to cover the top 20%. So if I go like this and click OK, we're going to get the next item or next sales territory in the grouping here. So now these two cover at least 20% of the data set that we are looking for in our top. Okay, so we can also go ahead and do the bottom if we want to. I won't go through and do those examples in this case, but let's go ahead and carry on with the next filter. And that is going to be taking a look at the sum. So I'm just going to go ahead and go back down to here. Let's go ahead down to the value filters and go down to top 10 here. And this time what we're going to do is we're going to go in and choose the sum, like so. And this time what we want to do here is I'm going to go in and try and find the top sum values that are at least covering 20, actually I say $19,000 here, like this. And when I do that, we're only going to get this value right here. So Southwest should be the only one that shows up, like so. But now if I go back in here again and go back to the value filters and say top 10, now let's change this to $20,000. Now this one only covers up to $19,000, and it's once again going to bring, oops, I guess I should type in 20,000. Go ahead and click here, and we're going to get that next value in here again. So you can do it on percentages of the grand total, not this grand total right here, but the grand total as a whole. So if I just clear this, I can do the percentages with look at the grand total down here, and I can take a look at sums that I want to type in a hard-coded fashion as well. So a couple different ways to go ahead and take advantage of that top function. Okay, so that is it around filtering our data set. Now let's go ahead and take a look at sorting our data sets. So let's go ahead and go to our table over here. So what I'm going to do here is I'm going to click on the sales territory right here. And right now my list is already sorted in alphabetical order. So I've got Australia, Canada, Central, France, Germany. And if you go down the rest of the list, you're going to see it sorted that way. I can go here and sort from bottom to top. So now at the top of my list is United Kingdom, Southwest, South, East, Northwest. That type of sorting is nice sometimes. I'm just going to go ahead and switch it back here. But what if we want to go and sort on the dollar values over here? So let's go ahead and take a look at doing that. So we click on this and I can go over to more sort options. And now I have a little bit more control over how the sorting is actually happening. We can see right now it is currently sorting ascending on sales territory. So let's go in here, and instead of sorting by the sales territory from A to Z here, let's go and click on the order quantity. So let's go ahead and sort on that in ascending order. Go like this. And now what we're going to see is we've got the lowest grand total at the top, then the second lowest, third lowest, all the way down to the bottom. So a couple different ways in very basic manner here to go ahead and sort your data sets. And we'll also show you how to go ahead and do multiple sorts. So we've got the sort right now on the sales territory going from lowest to highest. But now what if we want to do some sorting within the product category? So I can go ahead and click on the product category here. I'm going to go to more sort options once again. I'm going to say ascending A to Z. And within that, within the actual product category itself, I'm going to go and sort on the total order quantity. And just notice here that right now the default is this is going in alphabetic sort, if you take a look at each one of these things here. When I click OK, now each one of these groups here will be sorted from lowest to highest within the actual product category. All right, that brings an end to this particular sub-lesson on filtering our pivot tables and sorting the data in the pivot tables. When building dashboards or reports for consumers, it is worth stepping back to get a handle on selecting the appropriate visuals for what is being measured. There are 4 basic presentation types that you can use to present your data. They are comparison, composition, distribution, and relationship. Unless you're performing data science activities, you will primarily use the first 2. In addition, trending is something that is often broken into its own category, as aspects of trending overlay both comparison and composition types. Over the next few slides, we will go through a few high-level questions you may ask yourself to help guide you towards selecting a proper visualization for your needs. Now let me be the first to say that this is not meant to be a comprehensive discussion on visualizations and how to use them to help tell stories that are easy to follow and digest. This sub-lesson is meant to highlight the need to think about the selection of visualizations and what should guide your choices. As we go through and create our pivot charts in subsequent lessons, we will highlight the requirements and why we chose the visuals we did. So some of the first questions you may want to ask yourself, are you trying to compare values? The following are useful for comparing one or many categories of data, as they can enable you to identify low and high points in the data itself. These are the column, bar, and line charts. Do you want to show the composition of something? The following are useful for showing how individual parts make up the whole. These are the pie, bar, and the variance of bar chart, stacked column, and waterfall. Are you interested in analyzing trends? The following are useful if you want to know more about performance over time. These are the line and the variance of line, and the column chart and the variance of the column chart itself. Are you trying to understand the distribution of your data? The following are used to highlight outliers, display normal tendency, and the range of data in your data set. They are the column and bar charts. Do you want to better understand the relationship between value sets? The following charts are useful for showing how one variable relates to one or more different variables. These are the scatter plot, bubble, line, and variance of line. So that's it. Here are some additional resources to help guide appropriate visual selection. The following site has a tool called the Chart Chooser, which will help guide you towards appropriate visuals. In addition, Juice Analytics has an online chart chooser as well to help you choose an appropriate chart. Please follow the links to learn more. And that brings an end to this sub-lesson. Pivot charts provide interactive, graphical representations of the data in their associated pivot tables. When you create a pivot chart, the pivot chart filter pane appears. You can use this filter pane to sort and filter the pivot chart's underlying data. Changes that you make to the layout and data in the associated pivot table are immediately reflected in the associated pivot chart and vice versa. Pivot charts behave much like standard charts do. You can change the chart type, titles, legend placement, data labels, chart location, and so on. However, there are some differences. Unlike a standard chart, you cannot switch the row-column orientation of a pivot chart by using the Select Data Source dialog box. Instead, you can pivot the row and column labels of the associated pivot table to achieve the same effect. From a source data perspective, standard charts are linked directly to worksheet cells, Well, pivot charts are based on the associated pivot tables data source. Unlike a standard chart, you cannot change the chart data range in a pivot chart's Select Source dialog box. Most formatting, including chart elements that you add and style, are preserved when you refresh a pivot chart. However, trend lines, data labels, error bars, and other changes to the data sets are not preserved. Standard charts do not lose this formatting once they're applied. And finally, some chart types do not work with pivot tables. The following chart groupings cannot use the pivot table directly as a source. They are the scatter chart, map, stock, funnel, tree map, sunburst, histogram, box and whisker, and waterfall. So let's go ahead and create ourselves a pivot chart based on this pivot table we have over here in our Excel spreadsheet. So what we're going to do is we're going to click on any cell within the pivot table. So I'm just going to go over here to the pivot table and click on a cell. We see that our pivot table's fields pane reappears. And what we're going to do now is we're going to go up to the pivot table analyze menu. We're going to go here, we're going to find the tools group, and we're going to click on pivot chart. So what we're going to do here in the insert chart dialog box is we're going to select the column chart group on the left-hand side, which we can see is already chosen by default. And we're going to choose the cluster column chart. So we can, if we want to, run our mouse over top of a sample of what each one of these would look like if we wanted to see what the data we have in that pivot table look like using these chart types. So you can just roll over each one of these things. I'm going to go back to the cluster column chart like I have right here. And that is what we want. So I can hover on top of it to see a larger preview of what that data looks like. And if I'm satisfied with that's what I want, I'm just going to go ahead and click OK. All right, so now I get the pivot chart appearing in my workbook. Okay, so what we're going to do next here is we're just going to reposition the chart here. So I'm just going to grab it and move it over here like so, and make it a little bit bigger like this. So we're just going to make it take up a little bit more of the screen so it's a little bit more visible and easier to see. And what we're first going to do here is go over to the pivot chart, and down at the very bottom of here, we're going to click on the sales territory right here, like so. And what I'm going to do is go in and change the sorting options of this particular chart, because we can see right now that it is sorted in alphabetical order by the sales territory name, like so. But what if we want this to sort a little different? So I'm just going to click on this, and I'm going to go to more sort options right here. And what I'm going to do is I'm going to go over to descending, and I want to do this in descending order by total order quantity, like so. I go ahead and click OK, and we'll now see that the pivot chart has resorted itself. And we'll also take a look at the pivot table over here. It has reordered itself as well. Keeping in mind that this pivot table right here is associated with this pivot chart over here. So any changes made in one are reflected in the other, and vice versa. So further to that, what I'm going to do here is I'm going to go over to my pivot chart. I'm going to click on my sales territory, and we're going to take advantage of some of the skills we learned back in some of the previous sub-lessons here, and I'm going to filter my data set. So what I'm going to do here is I'm going to go down to the values filter. I'm going to go down to top 10, and in this case here, I want to choose the top 5 items by my total order quantity. So let's go ahead and do that and click OK. And now we can see that here are our top 5. And lastly, what we're going to do here is we're going to take this pivot chart, now that we put it on this particular worksheet and showed you the interrelationships between the pivot table and the pivot chart, we're going to take this pivot chart and put it onto its own tab, and specifically we're going to move to this tab over here called Dashboard. So what I'm going to do here is I'm going to click on the pivot chart itself so that it has focus on my canvas. And what I'm going to do is I'm going to go up to the very top here. I'm going to go over to the Pivot Chart Analyze. And what I'm going to do is go over to the Actions area here, click on Move Chart. And what I'm going to do is I'm going to choose in the Move Chart dialog box here. I'm just going to click on this and say Dashboard, because I already have that tab already set up. go ahead and go like that. And now I have this pivot chart moved over here. So I'm just going to go and move it roughly like so, something like that. Maybe do a little bit of resizing because I am going to be putting some more visuals here in the next little bit. So I want to make sure we've got enough real estate for the dashboard. We're going to build here over the next few steps. So now that we have that particular pivot chart set, let's go and build ourselves another visual. So what I'm going to do this time is I'm going to go back over to my pivot table tab, like so. And I'm inside of this particular pivot table right here. And if I take a look at the name of it and go from the pivot table analyze, we're going to see that it is called the pivot table PVT total quantity by sales territory, if you read through this little pivot table name. And what I want to do is I want to make a copy of this pivot table so that I can build another pivot chart on top of the newly copied pivot table, which we're going to do right now. So what I'm going to do here is with my cell inside of the pivot table, I am going to go to select over here under the pivot table analyze actions group, go select and say entire pivot table, like so. And then what I'm going to do here is I'm going to go ahead and copy the pivot table. So I'm just going to use Control C. And what I want to do here now is I'm just going to go over to cell E2, just move it far enough away here, and I'm going to paste that. So now I have a brand new pivot table in my worksheet here. And I'm going to make sure I go ahead and give that a proper name. So I'm just going to go in here and I'm going to give it the name of PVT total quantity by order date. So I'll highlight back over in this cell, go over to here, and we'll see here that it gave it the name Pivot Table 1 by default. I don't like that, as we talked about in some of our naming conventions a little bit earlier. And just like that, we now have a second pivot table, which is a copy of the first one, both with different names. And now I'm going to take this particular new pivot table and build a line chart out of it. So first thing I want to do here is I want to reconfigure this particular pivot table. So what I'm going to do here is I want to remove my sales territories from the rows. So I'm just going to go ahead and go like this and just say remove field. And the next thing I want to do here is I'm going to add my order date over here down to the rows like so. And what I'm going to do is remove the order, or do next here is remove the order type and order status from the filter area. So I'm just going to go ahead and say remove field and remove that one as well. So try to do things a few different ways here as we go through these particular exercises. And now next what we're going to do here is we are going to right click on 2019 like so. So go over here, we'll right click on 2019 in this particular column. And what I'm going to do here is go down to expand collapse. And what I want to do here is I'm going to expand this entire field. So I'm going to click on this right here and expand this out so I see 2019 and then all the quarters like so. And now what I want to do here is I'm going to right click on quarter one here in the quarters column. And what I'm going to do is I'm going to go over and say expand collapse as well. And I'm going to say expand entire field once again to get us down into all the individual months. So we can see that we now have years, quarters, months, and the total quantities by those particular months in the pivot table. So with this data now being set in the pivot table, we can go ahead and build ourselves a pivot chart on top of it. So once again, I'm just going to make sure the pivot table has focus. I'm going to go up into the pivot table analyze tab, which is already selected. And what I'm going to do here is go over to my tools group, click on pivot chart, and we can see that we have a cluster column chart presented to us here. But that's not what we want. We are going to go over and choose on the line area. So we'll choose the line chart over in here. And then what we want to do is let's go over and find the line with markers. So we'll go ahead and take a look at all these here. Line with markers. And that just puts individual points on each one of the data points right here that we can see. Just hover over top of that visual and it shows you a little larger preview of it. And I like what I see and I'm just going to click OK. And it puts the pivot chart right here. We already know that this pivot chart is related to the pivot table we just worked on. So let's go ahead and get this pivot table moved over to our dashboards tab. So I'm just going to click on the pivot chart analyze actions group move chart. And once again, go over to the dashboard, click OK. And now I have my second chart sitting over here like so. So I'm just going to make this size roughly, this size of the very first visual we had on there. I'm not going to get too finicky about this right now because we can spend a lot of time making sure everything's pixel perfect. But let's start with this as our visual and go on from there. Okay, so one thing that we do want to go about doing is let's go ahead and rename that pivot chart. So I'm just going to go over into the pivot chart itself. So once again, making sure it has focus like so at some point. There we go. So that's the focus I want to give it. And what I'm going to do is go over to my chart name under Pivot Table Analyze where it says Chart 2. I'm going to go ahead and put that name in there like that. And now I've got the proper name for that particular pivot chart set up just like that. So we are done that pivot chart for now. So what I'm going to do is go back over to our pivot tables. So I'm just going to go over to pivot table here. And what I'm going to do is take a copy of this second pivot table that we just built up. And I'm going to go over to Pivot Table Analyze, go select entire pivot table, do my copy like so. So Control C, just move over a little bit my spreadsheet. Go ahead and drop it in like that. And next what we're going to do is make sure this pivot table has a proper name. So I'm just going to go and rename it. So make sure we're focused within the pivot table itself. Under Pivot Table Analyze, go and give it the name that we want like so. All right, so now what we're going to do is click back inside of this pivot table. And our fields list seems to have disappeared on us for some reason. And what we're going to do here now is go ahead and get rid of the years, quarters, and order date from rows. So I'm just going to go ahead and remove these like so. Now we're down to our total order quantity. And what we're going to do is put our product category. So I'm just going to go and find product category here in the fields list. And that we are going to put on the rows like so. And next thing we're going to do is go and drop what are we going to do next here? We're going to take these sales territories and put it into our filters, just like that. So we now have this pivot table set the way we want, and we're going to click our mouse back in it, go under Pivot Table Analyze, go over to the Tools group, Pivot Chart, and now what we're going to do is go over to our Insert Chart. We're going to select the pie chart right here. We will go ahead and click OK. That is now sitting in our Pivot Table tab, and I'm just going to go ahead and get this moved over into the dashboard sheet. So I'm just going to once again go to Pivot Chart Analyze, Move Chart, Dashboard like so, and get it brought over here. And I'm just going to take this chart and move it down over here like so. So we can see it right on the screen right about there. So the last thing we're going to do here with this particular pivot chart is making sure that it has a proper name. So I'm just going to go up here to the name property, put the proper name in like so. And next what we're going to do is just show you some of the downside of the pie chart itself. Now, the way this pie chart is set up, it's really difficult to actually see which one of these product categories is actually larger, which one's the second largest, third, and fourth, because it's not immediately apparent to the first glance that you make on this chart. In fact, you'd have to really look at this hard to figure out which ones are the biggest, second biggest, third, and so on. And that goes with most pie charts. So what we're going to do here is move this particular chart to a different style. So what I'm going to do here is I'm just going to right click on the chart itself, and I'm going to say change chart type. And what I'm going to do here is I'm going to actually change this into a bar chart. So I'm just going to go like so and go to the bar chart, and I'm going to choose on the clustered bar chart like that. And we can see now that it actually ranks things a little bit better. So it's a little bit easier to actually see which ones are largest and which ones are smallest. And maybe to actually make this a little bit easier to see on the chart, we are going to go to the product category, click on that. We're going to go to more sort options, and we're going to say descending, and not by the product category, but by the total order quantity like that. And what we can see now is, whoops, made a little change there. And we can actually see now that it is ranked from lowest all the way to the highest. Okay, so that is 3 pivot charts that we created in this particular sub-lesson, and we showed you how they're related to their underlying pivot table and how to go ahead and create multiple pivot tables to support these charts. And you'll notice that is one thing you're going to do an awful lot of when you're building pivot charts is you're going to create a bunch of pivot tables to support those. So don't be surprised if you start seeing the pivot table count in your workbook start to increase to support the pivot charts that are underlying them. So with that, that brings us to the end of this particular sub-lesson. When building pivot charts, you typically start out by getting the pivot chart functioning properly from a data perspective first. Once you have it displaying the data you want, the time will come to give your pivot chart a professional look and feel. In this sub-lesson, we will focus on formatting pivot charts. So what we're going to do first is we are going to ensure that chart number 1 has focus, like so, and we're going to give this a new style. So what I want to do is I'm going to go up to the Design tab, like so, and I'm going to go over to the Chart Layouts grouping right here, click on Quick Layout, and I can just sift through the different layouts that are available here. So I can click on Layout number 1. It shows you what chart elements are included in Layout number 1, and number 2, and number 3. So you can go through each one of these things on your own. I'm going to choose layout number 4 here, and I can see that it has a legend on the bottom. It has data labels on the outside end, horizontal axes, and a vertical axis as well. So I'm just going to go ahead and choose that. And now my chart looks like that right there. So one thing that we can see with this particular chart layout that we chose is that there's no chart title. So we want to go ahead and add one of those. So what we're going to do is we're going to go up to the top here, once again under the Design tab, right next to Quick Layout where we just were. We're going to click on this drop-down box beside Add Chart Element, and we can see a number of the different chart elements that we can actually add to any of our visuals. So I can go through the whole list here and take a look at it, but what I really want to do is I want to add a chart title. So I'm going to select on that, and right now we can see it as none because that was part of the original Quick Layout we chose. And I'm just going to go down here and choose above chart or centered overlay. So it lets us show a couple different ways to lay this out. And I'm just going to say above chart like so. So now I have a title on my chart. So what I'm going to do here is I'm just going to go ahead and put a proper title in here because I've got the actual space for it now because now it's been added. And I'm just going to go ahead and paste that in like so. So total order quantity by sales territory, like we have there on the screen. Okay, so the next thing we're going to do is we are going to take this vertical axes, the values here, and we're going to change the scaling. So we can see right now that we've got the values showing like this. But what I'm going to do here is I'm just going to highlight on the chart, and then on the vertical axes here, so I can see the vertical values axes, I'm just going to double click on this here. And for some reason, oh, there we go. Now it finally showed up. I've got the Format Axes pane over here. And what I'm going to do here is just go down below on the axes options here under this right here. And I'm just going to go down a little bit lower here. And I'm going to choose this display units. Right now it says none. And I'm going to go ahead and change this to thousands. So I'm just going to go over here and say, put that in the thousands. And now we'll notice here that on the axes here, it says thousands, and then just changes the display units of these numbers right here. So now my chart looks a little neater and cleaner to read. I've got a title on it, plus my axes just looks a little bit nicer. And lastly, what I'm going to do with this chart is just click on it once again here, and I'm going to go up into the Pivot Chart Analyze here, and maybe I want to turn these field buttons on and off. So I can click on under the show hide here, click on it like that. And now I can see I can make my chart a little bit larger by getting rid of those buttons we can interact with. So I can turn them on and off like so just by clicking that. I can go in here and I can choose what do I want to show. So I can, do I want to show the report filter buttons, the legend filter buttons, axes, etc. and so forth. And just go ahead and play around with those as I see fit. So I'm just going to go ahead and leave my visual like that because it gives me a little bit more real estate and maybe displays the data the way we want it anyhow. And just as a final thing to show you here, on the chart styles here, because we basically went through the quick layout, gave our chart chose one of the quick layouts here, played around with one of the chart elements, did a little bit of formatting on the chart itself. We can go in here, we can choose the different colors. So there's color schemes that we can choose. I'm going to leave it at the default, which we have already selected here. Now there's a number of different chart styles we can choose on, so you can just kind of hover over each one of those and show different variations of what the chart would look like under these styles. Once again, I'm just going to go ahead and leave my chart as a simple design like I have right there, because I think that's good enough at this point in time. So with my first pivot chart formatted, let's go and format the remaining two. So let's go ahead and give them some proper titles here. So I'm just going to go and click on the chart title itself. And let's just go like so. Maybe that font size is just a little large there. Maybe we want to make it similar to the font size we have over here. So I'm just going to go over into the other chart itself here momentarily here. And what I'm going to do here is I'm going to click on the title in the first chart that we just went and formatted, and I'm going to go to my Home tab, go to the Format Painter, click on that. So now that we've got the style of that particular title chosen, I'm just going to move over here to this title and click on it, and now we can see that we have the same fonts and bolding on both of these particular titles. And finally, let's go down to our order quantity by product category chart, the very last one we have created here. And I'm just once again going to do the exact same thing. Just go ahead and drop that in there. And I could have done these all at the same time. Once again, I'm just going to go over here, click the Home tab, Format Painter, go back down to there, and now we've got all of these with proper titles and the same look and feel across each one of them. All right, so let's now move up to the chart we have over here, so our line chart, and just show you some of the things that we can do to interact with it. So if I want, I can click on the minus sign to collapse my entire field. So if I want to start collapsing these things down from the month level like I have it like so, I can click on that. That'll take me up to the quarters in the years. Click on that again, that'll take me all the way to 2019. And if I want to start drilling down into that chart, I can click on the expand, and it takes me down to the look and feel that we had a moment ago. So just a couple things that you may have noticed pop up on the side of the chart here. So when I had this particular chart selected, you'll notice that this little paintbrush showed up where I have my chart style. So keep in mind, we did this a moment ago up in our design tab, and then over here is where we can take a look at the different chart elements that we have on our particular chart. So we can go through and play around with these, much like we did back up in the design tab as well. So a lot of different places you can go ahead and perform the formatting you want to do for your particular pivot charts. And we're not going to go into too much more detail here around the different things you can format on the chart, but what you can do is basically click around in the chart itself. If we click on the chart title, you'll notice over here in the pane it says Format the Chart Title. We go over here, we can click on the plot area. We can see the Format Plot area comes up. The Format Axes. There's our other axes there. So we've got a number of different things that we can start to format the legend. Once again, go over and start taking a look at the chart area options that we have available to us. So you can really just start playing around and going into each one of these different areas and exploring really the different things you can do with your charts. And that's one thing I typically always encourage people to do is take the examples we have here and just start playing around with them and see what happens here. There's no fear of breaking anything. If something doesn't quite work out right or it breaks on you, you can just hit the undo button and go back to it and just start really playing around with all the different format options, because in a lot of ways, the sky is really the limit on these types of things. So the last thing I'm going to do for each one of my charts here, just before we get ready to close off this sub-lesson, is I'm just going to go into my, the Pivot Chart Analyze tab. I'm going to turn off the field buttons on all of my charts here so that I have this. And now I have all the charts with a lot more real estate and showing us everything the way we want it to look without the clutter of all those different buttons. Now, if people did want to have them there for interactions sake, you can leave them there. But for this example, I'm just going to remove all of them. All right, so that brings us to the end of this particular sublesson. All right, so we are going to round out the lesson on authoring interactive reports by creating an interactive dashboard in this particular sublesson. So what we're going to do here is we want to show how we can interact with this dashboard and have all the different visuals react to filters that we're going to place in certain locations. So in particular, we are going to do a timeline and we're going to set up some slicers. So let's go ahead and do that. So what we'll do first is we're going to click on one of our pivot charts. And what I'm going to do is go up into my Pivot Chart Analyze tab. And what I'm going to do is click on Insert Slicer. So I'm just going to do this. And what's going to do is ask me, what do I actually want to put that slicer on? So I'm going to choose the sales territory. So I'm just going to choose sales territory as a slicer like so. And it's going to drop a slicer on my canvas like so. And I'm just going to go ahead and move that over to here and space it out just a little bit more like this, just to kind of get it all set up. And we're going to do some further formatting on this particular slicer here momentarily. So first off, I'm just going to give the slicer a little bit more real estate to breathe here. So I'm just going to insert some rows here so that I can go ahead and drag this and make it just a little bit bigger so we can show a few more tiles in there. With the slicer still highlighted, I'm just going to go over here and I'm going to say that I want to maybe include a couple columns in this. I'm just going to go over to the slicer tab under the buttons group, the very top row of columns, and I'm just going to go and maybe put 4 in there so I can see all of the different options we have. Under 5 gets a little too scrunched, so 4 seems just about right for that particular slicer. And what we can see here is, given that I initiated the creation of the slicer from this particular visual here, this will be the only visual that responds to changes from the slicer. So I'm going to choose Australia and watch, only the first visual changes. And we'll see here that we've got Australia as the sales territory because that's what we have chosen up here. We can choose Canada. And now we see that Canada's been chosen. I can actually choose multiples here. So the way to choose multiples is by using the Control key. And now I've got Australia and Canada chosen on the visualizations. So if I didn't want to hit the Control key as I was choosing multiples, I could click on this little icon right here. It is called the multi-select. So once I click on that, we'll see it turns on. And now instead of hitting the Control key, I can just go and choose as many of these as I want. If I want to turn it off, I just have to click it again and turn it off like so. Okay, so that is going ahead and putting the slicer into the table. But now, maybe I want to make this slicer right here affect these other pivot charts. So we're going to show you how to go about doing that by ensuring the slicer has been chosen. Under the slicer tab, we go over to the left-hand side here and it says slicer. And we want to choose report connections. So we click on this. And what it's doing here is it's listing out the pivot tables that we have created. So this is where having good naming conventions behind your pivot tables will really help things out an awful lot. Because now I can go through this list of pivot tables here, and ultimately at the end of the day, I'm going to choose them all anyhow. But if I had a lot of pivot tables and I was trying to decide how to mix and match my report connections, it would be much more apparent with good naming conventions. So now what I've done is I've hooked it up so this slicer right here is going to impact this pivot chart right here, this pivot chart right here, and this one. So all three are going to be impacted by this. So I'm going to go ahead and click OK. And you'll notice that all these pivot charts changed. So this one stayed the same because we were originally navigating with it. But over here, these pivot charts changed. So now if I go and choose Central, we'll notice that these ones react as well. Add France into the mix. And now everything is just reacting to what I have here in the slicer. So let's go ahead and setting the slicer up. So now next, let's go and get ourselves a timeline set up. So once again, I'm going to choose on the total order quantity by sales territory here. Go up to Pivot Chart Analyze. I'm going to say Insert Timeline. And the timeline requires that we have a column in here that is of the that has dates in it. So I'm going to choose the order date like so, and we'll see a timeline shows up, which I'm going to put right in here-ish, like so. Let's get right about there, and then just resize the timeline like that there. And now I've got a timeline for all of my data. Once again, this is only impacting this first chart right here. So the way that I go ahead and change this to impact all charts is basically the same way I did it back in the slicer. Click on Report Connections and go in and choose the pivot tables we want to connect this into. So now we can see that these have all been impacted, and I can choose individual months like I'm doing here. I can actually drag on this slider and choose multiple months like this right here. If I want, I can actually change the scale of this to years. So I can, in the actual timeline, choose years, and now go and choose individual years like that. That's the entire data set. Go down to quarters, months, or even down to the day level. So I can play around with these in any way that I want. So I'm just going to go back down to my month here, and let's go ahead and choose April, and choose May all the way back down to, not April, I guess I should say, from May all the way to the end of July. And now this is what our data set looks like. So we can give ourselves a little bit more real estate here now that we've got things set the way we want. We can just double click on our menu up here, and now I've got a little bit more space for my dashboard, and now I can actually start interacting with it at this level. So one of the really nice things about the slicers and timelines is you can make them affect multiple pivot tables. And once again, keeping in mind that your pivot chart is associated with the pivot table underneath. So we do go about impacting both at the exact same time. And that is different than, I'm just going to go over to my pivot table tab here from before. And that is different than going over to the actual pivot table itself. And I just go ahead and get the field list set back up here and taking advantage of the filters that are at the pivot table level, because these filters right here can only apply to one and only one pivot table. Whereas if we take common filtering that we want to apply across all of our pivot tables / pivot charts, we can move them out of the filters pane here and build them into slicers and timelines, and then we can create more interactive visualizations and dashboards. All right, so that brings us to the end of this particular sublesson.
As we have previously discussed, every Excel workbook exists within a larger ecosystem of objects, including macros, versions, and other workbooks. Mastering collaboration and distribution requires knowing not only how to connect workbooks with these other objects, but also how to share workbooks' data with other users. In previous lessons, we have been working on spreadsheets independently, managing our own process to get it just right. Now it's time to share our work with others. In this lesson, we will inspect our workbook for issues related to hidden properties or personal information that we may not want to share with others. We will check for content that people with disabilities might find difficult to read. We will review for possible compatibility issues with other versions of Excel. We will review collaboration features within Microsoft 365 that allow us to avoid version control issues. We will set up appropriate content protection to avoid unintentional changes to formulas, formatting, and layout options. And lastly, we will go over some Excel functionality and best practices when setting up documents for print. Let's begin.
When you share an electronic copy of an Excel workbook, make sure that you review the workbook for hidden data or personal information that might be stored in the workbook itself or in its document properties. The Document Inspector feature in Word, Excel, PowerPoint, or Visio can help you find and remove hidden data and personal information in documents that you plan to share. However, some content can be found and removed automatically, while other content is found and you need to handle it manually. The following content can be found and removed automatically: comments and annotations, document properties and personal information, headers and footers, hidden rows and columns, hidden worksheets, custom XML data, and invisible content. Content that is found but you need to handle manually are the following: external links, embedded files or objects, macros of VBA code, BI features with cache data, Excel surveys, scenario manager surveys, filters, and hidden names. Let's take a look at the following document and see where its document issues are. What we can do here is go to the Backstage view. So we'll click on File, click on Info, go over here to the Inspect Workbook section, click the drop-down box that says Check for Issues, and we'll choose Inspect Document, which is going to check the workbook for hidden properties or personal information. So let's go ahead and do that. It reminds us that we should save our changes because the document inspector might remove data that can't be restored later. There are certain features in here that will be removed, and you cannot use the undo button to recover from. So we're going to say no because I have backup copies of this file already. And we can go through and take a look at what we want the document inspector to look at. So right now, everything is on by default. So we can ask the document inspector to look at comments, properties and personal information, the data model, content add-ins, and you can just scroll down the list here and take a look at all the different things that you want the document inspector to look at. And we mentioned all of those on the previous slide. So what we can do at this point is just click Inspect. And what it's going to do is let us know what we can go ahead and remove automatically or manually. So if we scroll through the list here now, we can see on the comments here, it says the following items were found, comments. And we can click on here to go ahead and remove all the comments from our document automatically. So I could click that and remove things. Our documents and personal information, we could go ahead and get rid of those. And if I scroll down just a little bit lower, things like active filters were found as well, but we cannot remove those for you. So we need to actually go in and manually do those ourselves. So here's an example of some of the things we can do manually. So the active filters here, and some things that we can go through and do automatically just by clicking Remove All. So it's really important to go ahead and do this, but go into the inspection mode being fully aware that some changes cannot be undone. That's why it asks you to go ahead and save a copy of the document before you go ahead and run the document inspector. So let's go ahead and remove some of the information from this document. I'm just going to go ahead and remove one thing. So let's go to the document properties and personal information here, and let's just click Remove All. Before I do that, I'm just going to move the window over here, and we can see the information about this document that we are about to remove. So I'm just going to click Remove All, like so. And what you'll notice here is in behind the scenes, all that personal information was removed. So now if I scroll back up to the top here, it says now the document properties and personal information, they've been removed. So if I want to go ahead and do a re-inspection of the document, I can do that by clicking Re-inspect. And I'll just choose what I want to have inspected, go ahead and inspect. And we'll now notice the document properties and personal information are free and clear here. So we've successfully removed that information. Going down a little bit lower and doing another one here is these active filters. It says active filters were found. We can't remove these for you. So we need to go in and do this ourselves. So what I'm going to do here is close the document inspector off. I am going to go back over to my table that has the document filters on it. I'm just going to go in here. I'm going to manually do this. I'm just going to clear my filter from sales territory. I am going to go in here, and there are no other filters on this table here. So I can see no other filter has been applied. Let's go back over the Backstage view, Info, check for issues, Inspect document. Once again, gives me the warning. I'm just going to say no. And I'm going to go in here and click Inspect again. And if I just scroll down here, we will go and find our active filters have now been cleared because I went in and manually removed those on our own. Okay, so if you've seen so far, the document inspector is a good way to go ahead and help and find the personal information that you may want to remove from your document, whether you need to do that manually or automatically. It allows for both. So that was a nice little spin through the document inspector. And with that, this brings us to the end of this sublesson. Before sharing your spreadsheet, Run the accessibility checker to make sure your content is easy for people of all abilities to read and edit. The accessibility checker helps ensure your workbook meets accessibility criteria. It will do the following. It will find most accessibility issues, but a manual check of the workbook is also recommended. It will explain why each issue found might be a potential problem for somebody with a disability. It will classify issues into errors and warnings, which we will discuss momentarily. And finally, it will offer suggestions on how to resolve each issue. Errors in the accessibility checker are things such as any non-text content that does not have alternative text, tables that do not specify column header information, cells in Excel worksheet that do not use red only, the color red that is, formatting for negative numbers, and documents that have restricted access. Warnings in the accessibility checker are things such as a table that has a simple structure, sheet tabs that do not have meaningful names, and any text and background that do not have sufficient contrast between them. Next, we will discuss the compatibility checker. In this case, maybe your organization is upgraded to a new version of Excel, or in the process of upgrading, and you realize you'll be sharing your workbook with people who have not gone through the upgrade process yet. The compatibility checker can help you identify features or information that may not be available in an earlier version of Excel, so you can then resolve potential issues before you share your workbook. Issues that cause a significant loss of functionality will cause a permanent loss of data or incorrect functionality. Issues that cause a minor loss of fidelity will not lose data or functionality, but the workbook might not look or work the same way when you open it in an earlier version of Excel. So let's go ahead now and take a look at some of the accessibility issues we may have. So I'm going to show you a couple different ways to get at the accessibility checker. First, what we'll do is we'll go into the Backstage view. So we'll go File, we'll go Info, check for issues, click the drop-down box, and we can say Check Accessibility. So let's start it this way. We can see on the right-hand side of the screen, the Accessibility Checker pane has identified some errors and some warnings. Let's take a look at the errors first. What we can do here is we're going to click on the little expander view right here, and we can see that there's missing alternative text. So if we go ahead and click on that, what's going to happen is that we will notice that this image over here does not have any alternate text. So if a screen reader were to go ahead and read this, it would not have any idea how to identify or describe that particular item. And we can see down below, it gives additional information on why you should fix this and what the steps are to go about addressing that. So what we can do here in this particular case is we can right-click on the object, and down at the bottom it says Edit Alternate Text. We can go like that. And what we can do here is just put a description here. So let's just say AdventureWorks logo, something nice and simple. Something like that. So when I go ahead and enter here now, we can see that the error has gone away from that particular item that did not have the alternative text. I can click on the next error here and say there's an exclusive use of color, so I can click on this right here, and it's letting me know that for these pieces of information here that have negative numbers, and they only show up in red as opposed to having the negative sign as well, it's giving me some issues with those. To go ahead and correct this error, I am just going to go up to the top here, and instead of choosing currency, I'm going to go down here and choose accounting. So we can see here that in this particular column, we have some issues of the exclusive use of colors we've mentioned. So what I'm going to do here is I'm going to go through this entire column right here over in the actual spreadsheet itself, and I'm going to go ahead and reformat this. So I'm going to go from currency and change this over to accounting. So now we can see that, yes, we are using red numbers to indicate negative, but we also have a negative sign over here to help somebody who may be colorblind. And now that we've done that, the error has gone away. So let's take a look at some of these other issues. We're not going to go ahead and fix these. So some of the warnings, which we just are warned about here, is the merge cells right here. We have the sales title as being merged, It's letting you know that here's the issue and here's how to go ahead and fix it, and all the different steps. And we can go down here and take a look at this next warning that says there's hard to read text contrast. So let's go ahead and find those ones right here. So we can see that we've got some data that is still hard to read. So we've got this red here. So it's identifying the red as something that's going to be difficult for somebody who is colorblind to potentially see. And if I click on this next one down here, where I have these columns that say sales representative, but they're a very faint blue, the contrast just isn't there to support accessibility. And once again, it will let us know why we should fix this and the steps that we should go about to go ahead and fix these. And finally, one nice feature that you can do inside of Excel here is we can click this little box right here that says, keep the accessibility checker running while you work. What that'll do is in the bottom left-hand side of the screen, the accessibility checker will continuously run, and as you build your workbooks up, it will let you know when you run into issues that are causing accessibility challenges so you can address them immediately. Okay, so now let's take a look at the compatibility checker. So what we're going to do here is I'm going to turn off my alternate text pane. I am going to turn off the accessibility pane over here as well. And I'm going to go to my backstage view. So I'm going to go File, Info, and go to Check for Issues and Check for Compatibility. So what this is going to do here, I'm just going to make this a little bit bigger, is this is showing me the things that if I move down to a different version of Excel will cause a significant loss of functionality, and the things that will cause a minor loss of fidelity. One of the things I can do here too is I can choose the versions of Excel that I want to do my compatibility checking with. So maybe I want to go ahead and turn off my Excel 97 and 2003. So I do that, we're going to see that most of the issues go away except for this one significant loss of functionality here. So let's go ahead and investigate that one. So this issue is letting us know that one or more cells in this workbook contain a threaded comment, and that these comments will be removed. So let's go ahead and see where those are. So I'm just going to click OK. And what I'm going to do is go find those comments. So what I can see here when I come back to my document is if I click in this cell right here, I've got a threaded comment in my document here that I would need to go ahead and remove if I want to save it in a previous version. So what I can do is I can click these ellipses right here, and I can actually say resolve the thread or delete the thread. Let's just go ahead and delete this. And now I'm going to go back over to my compatibility checker. Let's go to the backstage view, check for issues, go to check compatibility. And I'm going to knock Excel 97 2003 out of the mix here. And now we can see that our workbook is free of any compatibility checker issues. So once again, we run the compatibility checker just to make sure that if we were planning on sharing this workbook with somebody who had a lower version of Excel than we did, that we could figure out where those issues actually reside. With that, we are now at the end of this sublesson. In this sublesson, we will discuss how to best share and distribute our Excel work. If your first thought was to email your document, then stop right there. We will look at collaborating on documents and some of the features of Microsoft 365 that allow you to avoid version control issues and reduce what is being emailed around. This benefits security, versions, and filling your email box with giant spreadsheets. Let's face it, we collaborate now more than ever. And traditional sharing means such as email network drives create challenges with driving collaboration and are no longer effective. Our workforce is dispersed. We have users that are internal to our organization and may be working in many locations and/or time zones. And now, we may have external users to our organization that we may want to have collaborate on our documents as well. We have a diverse workforce that has skill levels and all kinds of different experience. And we need to work on driving engagement across all these different organizations and our diverse workforce. So how do we do this? We want to enable collaboration anywhere, anytime, and on any device. To support this, we'll explore the following features. We'll talk about co-authoring documents, commenting, and taking advantage of version history. So first, let's talk about co-authoring. So Amul and I want to open up and work on the exact same workbook at the same time. And as a note, Amul and myself are actually in different organizations. So I'm operating out of my Iteration Insights Microsoft 365 tenant, and Amul is going to be operating out of his Stratson Consulting Microsoft 365 tenant. So not only are we sharing documents, we're sharing across organizations. So whenever we co-author, you can see each other's changes quickly. In fact, in a matter of seconds. And with certain versions of Excel, you'll see other people's selections in different colors. The versions you can see this in are Excel for Android, Excel for iOS, Excel Mobile, and of course, Excel for Microsoft 365. If you're using one of these versions, you then select Share in the upper right-hand corner of the spreadsheet, which we'll get into in a moment here, and go ahead and choose the person's email address you want to share with, and the sharing and co-authoring features will be enabled. So let's go ahead and get this spreadsheet open here. So I'm actually on my desktop right now, and you can see I've got an Excel spreadsheet highlighted here. I'm just going to go ahead and open this on my desktop to show you some of the things that we have to do first to enable sharing. So here's the file on my desktop. If I do want to go ahead and share this with Amul, I can go ahead and click on Share in the upper right-hand corner here. And the first thing it's going to ask me to do is actually take this file and load it up into OneDrive, because right now it's just sitting on my desktop and there's no way for us to share and do the co-authoring until the file's sitting within our OneDrive or SharePoint Online. So I'm just going to click on OneDrive here, and it is now loading a copy of this file off of my desktop into my OneDrive. And the first things I have to do here is I have to choose who do I want to share this with. So what I'm going to do here is I'm going to go down and choose specific people because Amul is who I actually want to share this document with. So I've gone and I will get his email address typed in and in a moment here. And what I want to do is I actually want to click on this Allow Editing, because part of co-authoring is enabling not only Amul to see my document, to actually be able to edit it as well, so we can work on the document at the same time. So I've chosen specific people. I'm allowing editing. If I didn't have this Allow Editing on, I can actually block the file from being downloaded as well by clicking that toggle switch. But that's not what we want to do, because I want to actually enable the co-authoring process. So I'm going to click Apply. Next thing it's going to do is ask me to put an email address in here. So I'm just going to start typing Amul's name in. Amul pops up like so. And I'm going to get a notification here, and this is pretty important. Is it's letting me know that Amul is actually outside of my organization. So keeping in mind a moment ago, I mentioned that I'm actually inside Iteration Insights Microsoft 365 tenant with the Excel spreadsheet in my OneDrive, and I'm going to share it over to Amul inside of his Stratson Consulting Microsoft 365 tenant. So now that I've done that, I'm going to go ahead and click Send, and it let me know that the file's been sent off to him. So in a couple minutes here, Amul will get an email notifying him that he can see the document. And I'm going to show you where to go and manage the permissions. But when he actually gets into the document, you're going to see his initials pop up here in the right-hand corner, indicating, oh, there he is already. So that happened pretty quickly. So we can see that he has gotten into the file here. But before we start doing some collaboration work with him, let's go ahead and show you where we can view who has access to the file. So once again, I clicked on Share, and I'm going to click on these three little ellipses right here and click on Manage Access. And right down below this link here, I'm going to see that here's the people that I specified can actually edit the file. And it's letting me know that Amul is the person who has access to it, and he's an external user. So that's great. If I wanted to remove him at this point, which I don't, I could go ahead and click this X. But this is where you can go in and manage some of your permissions. Now, you can actually do this in your OneDrive as well, but we'll just focus on the Excel side of the equation to start with. So I'm just going to go ahead and close this off. And we can see that Amul's actually in the file here. And I can see that he's on cell F5. So in this dialog box, it's letting me know where he's at. And I can see this blue ring around F5 right here, indicating that this is where he is actually editing the work. So what we're going to do here is I'm going to see if a Mool can go ahead and change this data here to $10,000. But first, I'm going to actually use another feature here in Microsoft 365 to drive that collaboration. Because maybe we're not on the phone working together, or maybe we're actually sharing things verbally. But I'm going to go up and actually send over some comments here. I'm just going to say, actually, let's go into this one right here. I'm just going to say new comment and say, let's change these to $10,000 for the rest of the year. Something like that. And let's get our, like so. So I can go ahead and click that. And now he is getting that comment there, and he will go ahead and edit this data here. So we're going to see these changes here really quick. So he's gone and already made the change to the $10,000 there, and we can see that everything has been moved over as requested. So what I'm going to do is I'm actually going to make some changes myself, and I see he's already replied that it's done, and I'd say thanks very much. So I'll just go like so. Oops, shouldn't hit enter. I need to hit that send there. And here we can actually see our entire collaboration chain directly inside of this email. So I'm going to go ahead and change my values in here to $5,000 for the one right below it, like so. Okay. So what we're going to do here next is, let's just suppose a couple days went by and we wanted to revert this spreadsheet back to the original values. So now I want to go ahead and show you some other features inside of Excel, is the ability to go back and revert to other versions. So what we're going to do here is I'm just going to go into my comment stream, and we have to kind of play this story out a little bit here. I'm just going to go and say, Amul, why did we go ahead and change these values? Why did we change this to $10,000? And pretend this is a couple days later here. So we're kind of doing this example live. So I said, why did we change this to $10,000? And we'll wait for Amul's reply back in the window there. And we can maybe go about doing some other work as he's getting ready to reply to me. Oh yeah, that's right. So we did it based on the new numbers from accounting. But let's go ahead and actually, I'm going to tell him I want to revert these values back. So what I'm going to do here is I'm going to go in and let him know that I want to revert this back. So I'm just going to say, let's revert these values back. And what I'm going to take advantage of is version history within Excel. So what I'm going to do here now is I'm going to go to the very top of my document right here, and I can click on the name, and I can actually go and take a look at the version histories that are out there. So I'm going to click on that right here, and I can see that we've got a few different versions of this file. Now, keeping in mind that in this example here, it's only a few minutes old, but I want to go back and take a look at what the original version actually looked like. So I'm just going to click on that, and I can go and see that, all right, well, these are what the values look like before we did anything. Now I actually want to go back and get this restored back to its original point. So what we're going to do at this point here is I'm just going to click this restore button, and it let me know that somebody else is working in the file. So what I'm going to have to do here is I'm just going to close my file out really quick here and come back and then get this restored back into the actual version itself. Okay, so I've got the file back open now. So what I'm going to do is go back over to my version history, click on that there. It's going to go ahead once again and take a look at the different versions. I'm going to click on this original version here and click restore once again. And we're going to see now that the document has been put back to its original state. Now, keeping in mind here that I've gone back to the original state of the document as it was about 10 minutes ago. Now, keep in mind, we're trying to play out about a week's worth of activity here. But now I can go in the comments. You're going to notice the comments are all gone because as I went back to the original version of the document, the comments also went away with it. So at this point, as a best practice, it might actually be a good idea to go in and actually put a comment in here that we actually reverted this back to the original version. So I'm just going to go in here and say reverted back to the original version, something along those lines there, just so we know that, hey, wait a minute, we thought we had made some change to this. What happened? So this way now the comment is actually back in the document itself. All right, one last thing that I do want to show you here inside of Microsoft 365 is this autosave. So in the upper left-hand corner of the screen, you're going to notice we've got this autosave on. And what happens here is by default inside of Microsoft's 365 is what will happen is the document will be saved every few seconds automatically for you versus always having to remember to go in and hit the save button. So this is a new feature. It is enabled by default when data is stored on OneDrive, OneDrive for Business, or SharePoint Online. And one thing to point out too is now that this document is stored within Microsoft 365, if I go to the File menu, we're going to notice here that there is no file save as. So the only thing we can do is save a copy, do a manual save, or let the document just continue doing its autosave on its own. If I want, I can actually go ahead and turn that off. I'm not actually going to do the switch on it, and that forces you to go into the manual saving mode. So it's really up to you to decide what version of saving you want to do. I know myself, I tend to leave the autosave on for all of my Microsoft 365 documents, but everyone has their different preferences. All right, so that kind of concludes what we want to talk about here in this section on distribution and collaboration. There's some awesome things that you can do, and hopefully we're able to demo that here in this particular sub-lesson with Microsoft 365 that really drive the collaboration process. It really wasn't that long ago that we did things over network drives and email, and that really made the versioning and Excel management process quite challenging. And even just some of these features inside of Microsoft 365 we just demoed over the last 10 plus minutes here are a huge time saver and will make collaboration and distribution much easier. And so with that, this brings us to the end of this sub-lesson.
So now that we have authored our content, inspected for issues, compatibility, and accessibility, and collaborated with others to review and finalize our model, let's look at some options for protecting our content. The need for implementing such protection can be specific to the use case. However, there are some common scenarios that we would like to highlight. These are avoiding deliberate or unintentional changes to our content, workbook structures, sheet layouts, and formatting, protecting copyright or sensitive information, for example, formula code, implementing access control so only select individuals can read or edit our model, and finally, to ensure consistency and data integrity for our model. So in that context, Excel provides us with 3 protection levels. Worksheet protection to protect content and formatting on a specific worksheet, workbook protection to protect the general workbook structure, and file protection to prevent unauthorized access to content within our file. During this sub-lesson, we will review these options in further detail. In order to successfully implement adequate controls, it is important to understand the scenarios where each of these options may be applicable and are reliable. Let's review worksheet protection first. This capability allows us to protect specific worksheets within our model from accidental or intentional changes to cell content, worksheet layouts, and formatting. It also allows us to highlight specific formula code that we may not want the end users to see for confidentiality or other reasons. Finally, it provides the ability to selectively allow or prevent editing for specific cells, ranges, and objects on an individual worksheet. At this time, we would also like to highlight that sheet protection within Excel is a preventative measure, and it is not intended to be a security feature. Someone with the appropriate technical knowledge may be able to work around this protection level with ease. So for better security controls, we should be using one of the other protection levels we'll discuss in this lesson. Now let's review some uses for this capability. For this example, we'll use the prep budget and the report budget sheets from our lesson 4 content. For the prep sheet, we want to protect all formulas and formatting except for the manually entered data for base metric, percent change, and dollar change. To do this, we will first protect all cells on the sheet and then selectively unprotect the cells required for data entry. To protect all cells, we can select all content on the sheet using the arrow button in the top left corner. We can then launch the Format Cells dialog box using the Ctrl+1 keyboard shortcut. And on the Protection tab of this dialog box, we will confirm that the locked option is enabled for all cells. Now, if we were to protect our sheet at this point, none of the cells would be editable. So to allow editing for our data entry cells, we need to first select them. Then under the Home tab of the ribbon bar, within the Format submenu of the Cells group, we can toggle their lock option towards the bottom of the list. The last option within this same list will launch the Format Cells dialog box that we just looked at. Now, if we were to protect our sheet, only the data entry cells within the revenue section of our prep sheet would be editable. Now, another way to allow data entry while protecting other content on our sheet is with the use of Allow Edit Ranges capability. We can access this option under the Review tab within the Protect group and clicking on the Allow Edit Ranges button. This option can be used to allow certain cells to be unlocked for data entry or editing with or without a password. It also allows the author to enable such access for a selected number of users. However, when setting up the password for such cells or ranges, we will need to enable the Select Locked Cells option when protecting the sheet. This would mean that all users will be able to see formula code within protected cells by selecting them. So as you can see, some consideration may be warranted when enabling such protection options. Now let's implement the Allow Edit Ranges capability for the operating expenses section. To start with, we will click on the New button, provide a name for the range using the naming convention for our model, and then select the editable range of cells. Next, we can provide a password for this range, let's say test, and also modify the corresponding permissions. In our case, we will use the Everyone group and then check the Deny option so that the password is always required. As we click OK, the dialog box is confirming that the Deny permissions will override the Allow permissions in case of a conflict. Now, accepting our changes for this range, entering the password again, we will then apply the new configuration and then protect the sheet from the same dialog box. Here, we will first disable the Select Locked Cells option and then press OK. As you can see, we can now edit the values within our revenue section, but cannot select the cells within our operating expenses section. Now let's go back, unprotect our sheet, and then protect it again, and then this time we'll select the Locked Cells option. With this new configuration, we're able to select the cells within our operating expenses section as well. However, as we try to change values within this section, we'll be prompted for the password that we entered previously. Changing values within the revenue section does not require such password as it is outside the editable range we have configured. Now, if we unprotect this sheet, go back to Allowed Edit Ranges, and modify the range we had configured to change the permissions and allow editing without a password, apply our changes, and protect the sheet from the same dialog box, we'll notice that the cells within the OPEX section are now also editable without a password. In some cases, we may want to create a single password for the worksheet when protecting its content. We can do so using the Protect Sheet dialog box and providing a password at the top to unprotect our sheet. This dialog box also provides a few other options for customizing our protection level. While some options are self-explanatory and allow users to select locked or unlocked cells, insert rows, columns, or hyperlinks, delete columns or rows, and so on, we will now review some other options in further detail. To start with, the Format Cells option allows the user to modify cell formats, including conditional formatting. These options can be accessed using the Ctrl+1 keyboard shortcut we discussed earlier, or using the Conditional Formatting menu under the Home tab. Similarly, the Format Columns or Rows option will allow access to the relevant format options within the Cells group of the Home tab, and the Sort option will enable access to the Sort and Filter group items on the Data tab. Additionally, the Use Autofilter option will allow the user to change filters on ranges, and if we wanted to allow our users to create, format, refresh, or modify pivot table reports, we can leverage the Use PivotTable Reports option. Finally, the Edit Objects option allows the users to make changes to graphic objects on our sheet, including charts, shapes, text boxes, and other interactive controls. For example, this final option can be used for locking the charts on our report page from Lesson 4. However, before protecting the sheet, we should confirm that the charts we intend to lock have the corresponding option enabled. To do so, we can first select a chart, right-click within the white space, and select the Format Chart Area option. We can then go to the Size and Properties tab, expand the Properties section, and review the Locked option. We can modify this option for multiple charts by pressing down the Control key when selecting the target objects. Once selected, we can go back to the Size and Properties tab and then update the Locked option under the Properties section. Please note that in some cases, like interactive reporting scenarios, we may want to allow our users to move or edit certain charts. In such cases, we can either unlock the specific charts or enable the Edit Objects option before protecting our worksheet. So as you can see, Sheet Protection offers a variety of options to protect our content. However, these are applied at a worksheet level. To protect our workbook structures and layout by preventing users from adding, modifying, copying, or hiding and unhiding sheets within a workbook, we can use the Workbook Protection options. Once we have structured our worksheets in the required sequence and maybe hidden other worksheets that are not required by the end users, we can lock this customized structure using Workbook Protection. To enable this option for a workbook, we can go to the Review tab on the ribbon bar, and then click on the Protect Workbook button, provide an optional password before accepting the protection for our workbook. Once implemented, all options related to modifying the structure of our workbook will be disabled in the relevant menus. It is also important to note that protecting a workbook will not enable sheet protection for the worksheets within. This would have to be enabled individually for all worksheets within our workbook. Additionally, both protection levels we have discussed thus far are not intended to be security features. So in scenarios where we need comprehensive protection for our models, we should use Excel file protection instead or in addition to the previous options. Excel file protection provides a reliable security option by preventing other users from accessing the content within our workbook without the correct password. This can be used to restrict access to our models and encrypt the corresponding Excel file. To enable this option, we can go to the File menu, then Info, and then click on the Protect Workbook button. Here, we can select the Encrypt with Password option and enter our desired password. Now, similar to workbook protection, protecting the Excel file will not automatically enable the workbook or sheet protection features. These will have to be enabled separately as discussed previously. It is also important to note that Microsoft does not provide options to recover Excel file passwords, so we need to securely maintain it within our records. Alright, so with that, we have now covered the protection options available within Excel. You should now be able to implement a customized protection level for your next project. In addition to the electronic distribution of our models, quite often we will be required to generate physical copies to summarize the included analysis and results. In such scenarios, we will typically bundle our input data, some of the data preparation steps, and our final reports or dashboards with the accompanying notes as part of the standard print package for our model. For physical copies, we typically avoid the info and format sheets, release notes, source and reference data, and any other detailed calculations or schedules we might have prepared to assist with our model outputs. During this sublesson, we will review some options to prepare the content within our model for such print packages. Once again, we'll use the report budget sheet from Lesson 4 for this exercise. Now, most of the options we will discuss here are available on the Page Layout tab of our ribbon bar. Starting from the left, we have some options to configure the colors, fonts, effects, or the entire themes for our model. These options update the standard fonts and color palettes we use throughout Excel. For example, by selecting a different color palette here, we can change the look and feel of our dashboard with a single click. This can be extremely useful when reusing content for different clients. Next, for the page setup group, we can either configure specific options for this worksheet from the ribbon bar, or launch the page setup dialog using the pop-up button at the bottom right of this group. Here, under the Page tab, we have some options to modify the orientation, scaling, and paper size for this worksheet. In our case, we would like to have a landscape layout for this dashboard and print it onto 2 pages with a single page width. On the Margins tab, we'll update the desired spacing around our content to 2 and set the values for header and footer to 1. We will also center the content horizontally on our page. Moving on to the header and footer section, we will first create a custom header and use an online icon for our left section. We'll filter for small icons. Select one and insert, and then add the header for this page. Format the text. And also format the image to 50% of its original height and width. In Excel, we can use watermarks for our printouts by providing a photo for the center section of our header. So in this case, we'll use a draft watermark and then format it to be 150% of its original height and width. For the right section, we'll add some page counts and then click OK. Next, we'll configure the custom footer and supply the file name for the left section. At this point, let's preview our printout for this sheet. As you can see, our content is still not center. This is probably because our print areas have not been configured correctly. We can do that on the Sheet tab of our Page Setup dialog. Once on this tab, we can click on the Print Area input box and then highlight the cells we want to print. In addition to the print area, on this tab we have some other options for print titles, which are rows and columns we want to repeat on every page of our printout, toggles for printing guidelines, comments, notes, headers, row and column headings, and so on. And then finally, the page order for splitting content across multiple pages. The options to print comments, notes, row and column headings are quite useful when printing content like formulas for review. Now going back to our worksheet, we can select equal width for the columns around our content, and then confirm the print preview by using the Ctrl+P keyboard shortcut. Our content is now centered horizontally. We will also adjust some of the custom margins here to provide more coverage on the page. Going back to our worksheet, I'd like to highlight a couple of other views that are extremely useful when preparing our content for printing. So we go under the View tab, and then first select the Page Layout view, which can be used to review how our printed document will look. So it'll include the headers and footers and the overall page layout, including the page breaks. To review or modify where page breaks will occur in our content, it is best to use the Page Break Preview. Here, not only can we review a paginated view for our report, but we can also modify the page breaks for our content with ease. Furthermore, when dealing with objects like charts on our worksheets, we can selectively enable or disable their printing by selecting a chart, right-clicking and going to Format Chart area, then navigating to the Size and Properties tab, expanding the Properties section, and then modifying the Print Object option. If I were to now use the Ctrl+P keyboard shortcut, we can confirm that our report has been broken down into 2 pages, and also the chart that we just disabled for printing does not show on the preview. Our report is now ready for printing, and we can use this screen to configure some final settings for the content we need to print, which can be active sheets in case we want to print a package, the entire workbook, or a selection. We can also specify a page range to print from the preview on the right. Next, we can specify single-side or double-side printing, and some other options for collation, orientation, paper size, margins, and custom scaling. Upon confirming all these options, we can select the printer that we want to print this package to, and then click Print. Okay, so with that, we have now covered the options to prepare our models for printing and configuring our print options to achieve the desired results. You should now be able to configure the print packages for your models as per your client's needs.
You've completed your journey through data analysis fundamentals with Excel. You now have some great data analysis skills under your belt.
During this live lesson, we introduced a typical data lifecycle and Microsoft Excel's role as a technology within the lifecycle. We learned how to use get and transform data to extract data from source systems and then transform, cleanse, and load it into Excel. We then reviewed some fundamental concepts and best practices required for data analysis within Excel. We designed and implemented a sample data quality dashboard in addition to a budget and forecast model. We later authored interactive reports using a combination of pivot tables and pivot charts. And finally, reviewed our workbooks for collaboration-related issues while learning best practices for sharing and distribution of Excel-based data.
With all this knowledge, you're now much better prepared to take some big first steps in growing your career in the data analytics space. We hope this course furthered your knowledge of Excel, and we hope you enjoyed taking this course as much as we enjoyed teaching you. We wish you good luck in your future endeavors.